It's also just, you know, delicate and fun, and it's a temperamental robot, and we all love that kind of thing, don't we? Okay. So in TouchDesigner, what we're going to be doing to make it specific to TouchDesigner is we're going to be drawing out of the ScriptStop context. We'll talk really quickly about the CopyStop and stuff, but honestly, like, I really don't know a ton about stops. I'm not going to lie to you. Tons of people in this room know way more about the stop context than I do. So I don't actually, you know, have a lot to tell you about using the CopyStop. We'll talk about maybe sending stamped parameters back up the chain if we get to that stuff. But we're basically going to replicate a lot of those functions, and we're going to build up a whole bunch of tools in the ScriptStop context, and we're going to talk about how to use ScriptStop this way that I've developed that's like basically like writing yourself a little module and calling functions out of that. And so we'll build up some abstractions. We're going to start with abstracting the ability to drop a point, the ability to draw a line, the ability to draw a line from an array like a NumPy array so we can make this stuff performant. We're going to be talking about NumPy. And then we're going to be able to draw squares and circles. And then from that, we're going to be able to do these procedural drawings that are, you know, draw a circle of points and then draw a circle at every point and then draw another circle outside of that and change it a little bit and copy that and blah, blah, blah. That's how you get these kind of drawings that I've been doing. Let's do the unfun part here. This is getting you guys what you need. If you're on the internet, I have a gist that is going to make this a lot easier. The URL, if you just go to gist.github.com/ancillary magnet, I only have one gist. And you'll get the gist. That's why. And while you're doing this stuff, I'm going to make sure the robot works.
Could you make it a bit larger?
I think so. Okay. So if you can actually skip this Python probably and just make a virtual environment because it's whoopsie daisy. I'm sorry, what was that? Oh, yeah. Ancillary magnet. I'm sorry, that's what my company used to be called. It's a terrible name. I think I clicked that link, so this is about to get ugly. This entire workshop is on one network right now. So, did everybody get the gist? The URL? This part's going to take a while, so don't panic. I'm not going to leave you behind. This is what Elber's promised to help with. And I'll explain these steps once everybody's on the same page. Is everybody here? Okay. Oh, okay. Let me know when you... Anybody who doesn't have the gist loaded, you're still loading this page, right? Anybody else not have the gist page up yet? Everybody's got this. Okay, cool. Anybody who doesn't have it yet, I'm going to come... Okay, great. Is it just loading really slow? No. Oh, I see. Oh, okay, but if you go to github.gist.com/. Right? Yes. Well, that's fun. That must be the DNS here. Did anybody else have trouble getting to that URL? Did anyone successfully get to it? You did? Okay. We'll get to that in just 1 second. I just want to get everybody to the same spot. Sorry? I just want to get everybody on this page first, and then we'll do the steps. Okay, anybody else still stuck trying to get to this page? Just you, okay. And you too, okay, great. Maybe the problem is just localized to that part of the group. Oh, I see. Yeah, just how about you? Yeah, oh, okay. And you're on the, yeah, format.
There's just too much lines.
What's the file until?
Kind of connect.
footer. Okay, this part might take a little bit, especially because we're on the table. Goodness gracious. Should we just run this with these built in? Okay. I tell you what, I'm worried about us all being on the same Wi-Fi as the rest of the conference in this part, exploding the Wi-Fi. So as long as you guys are okay with it, we're just going to install this to your existing Python path. And we can use the built-in NumPy. We're going to do that. Okay, so let's just skip to this part right here. If you guys go to Matthew Reagan's GitHub, and here I'll open this in a new tab here. I feel like maybe we should just do this if people want to plot later. I tell you what, in the interest of time, when you're coming up to plot, we're gonna start putting together some drawings, and maybe we'll take a break for a second, and everybody can like do their own drawings and stuff, and then because the idea that a whole bunch of us are gonna print is maybe a little crazy. There's 31 people. This thing takes forever to print, and I'm just gonna fire it off while we go through this part. But I just want to make sure that everybody has an external text editor. So if you don't, please. I like Sublime Text. It's totally up to you. This is really not going to work if you don't configure TouchDesigner to use an external text editor. So I would say just as a recommendation, grab Sublime. You can use whatever you like if you're a Vim person. If you just want to use text editor or something. We're going to go into TouchDesigner here. I'm on another screen. And you're going to go to your preferences. They're on this screen again. Here we go. And you're going to go to the DATS config here. And for these two settings, you're going to configure it to use an external text editor. You're actually going to pick the program. So in your program files, I have Sublime 3, and you actually just pick the program itself and hit open. Let's just pause for a second while everybody gets that cracking, because this is impossible without doing that.
Also, in the meantime, we're looking for power bars, but you should try and make little tribes in your rows and just cycle cycle the power in the meantime. So get to know everyone around you. Because it's gonna be a juggling game.
If anyone needs.
Okay. Unless you got this guy's laptop, which needs like bulk power.
What version of NumPy is in Touch right now? It has NumPy though, right? Yeah, okay. Let me tell the robot to print to make sure that it does. Is there anyone that doesn't have an external text editor configured right now? You don't? Okay, cool. All right, okay. In the meantime, I'll fire off the robot so you guys get the idea with the excitement. So I just want to talk about the machine itself. One of the things that I'd really like to give you as a result of this workshop is just like skipping all the stuff I learned the hard way over the last couple months, so that if you decide you want to get into this, you don't have to go through all the trial and error things that I went through. And you're going to walk out of here with a library of drawing tools that are all primitives, so that if you want to get into like the kind of interesting generative drawing stuff, you can do that, hit the ground running, right? So the way the robot works is it has two belts that can move it in an X, Y, and we're calling this X and this Y. And then it has a little servo up here that can move this slide. I don't know if you guys can see this, but there's a carriage that holds the pen. And it just kind of holds the pen loosely. And there's a little servo that can lift that carriage up. It can only lift it up. It's underneath it. So when it lifts it up, that's so you can raise the pen. You can move from position to position without drawing. Totally up to you how much you want to raise it. If you want to raise it at all, sometimes I don't. I just see what comes out with the connections between things. And it drops of its own on its own accord from gravity. That is, if it's working properly. That was one of the things that was not working properly yesterday. It takes SVG drawing files in. It takes in vector files. And so one of the challenges that we have coming out of TouchDesigner is to get to vector. Matthew Reagan made a really great port of this tool called SOP to SVG, which is an existing Python library that's in that gist if you want to install it, that allows you to flatten SOP context to SVG. And when I say flatten, one of the other challenges that we're dealing with, you're used to in TouchDesigner when you render, or even when you look in the SOP viewer, you're looking at or most of the time, perspective rendered drawing with occlusion. If you turn on wireframe, you still have perspective, right? You could toggle that off and go to the orthographic view, and I'll show you that. Just so, I want to assume everybody knows what I'm talking about here. So if I make that's a rectangle. Here's a box. And if I hit A and I hit W, this is what the view normally looks like, right? And then if I go to display options, whoops, that's not it, right here, and I say toggle ortho perspective, now this is the orthographic view. So if I tumble this, you can see, that's interesting. If I tumble this, you can see that I'm getting an orthographic view. That means that I don't have a perspective on this, right? This is what SOP to SVG gives you. It gives you SOP space, and by SOP space I mean not world space, right? This is model space, so it's specific to the origin of this and the transform of this SOP context, wherever I end up connecting to SOP to SVG, and I'll show you that in a second, just that this isn't completely abstract. I have a null here that I'm feeding through a couple of tools that I made, and then we're getting to SOP to SVG, which is just a tox. And inside SOP to SVG, there's really just an extension that when I hit the pulse button, will fire off, and SVG, the robot is like right in my projection here, will fire off an SVG. So if I were to flatten this, and I'll just do it here, I don't even know what that drawing is, but circle, circles, circles. That's a good name, isn't it? I'm going to flatten this to an A4 document, and then if I go, and I'll just show you what a SVG looks like. What do I call that? Circle, circles. Here we go. Yeah. Some pretty on-the-nose machine drawing stuff, right? So this is a program called Inkscape, which is also in the gist. Don't bother downloading it right now. It's, I believe it's Qt-based, extremely slow vector drawing open source program. You could do vector drawing right out of it if you like, but this is pretty much the best way as an intermediate step to get to the robot. So it has an extension installed in it that controls the Axidraw, and you can use it to move your plots around and scale them and things like that. But here I have this plot, whatever it is, and I'm going to draw a box around this just so that we have a good box on the table on that piece of cardboard so we can see where we're headed. I think I'm going to draw a box. Good. And then I'm going to stroke it. This is not an Inkscape tutorial, but I just want to make this so that we have a plot box on the table. Good. Okay, so I just hatch filled this thing. And actually, let me move the box out of the way. Excuse me, box. Okay. I'll put the box back, and I'll just start the robot. So one of the things that you're setting up when you're drawing with the robot is the motor control stuff. So if I hit apply here, yeah, the pen goes up further. What they normally tell you to do is drop the pen down to about 2 coin heights if 2 coins were stacked on top of one another from the page when it's in the up position. And then you can check it. You can drop the pen and just make sure that it's making good contact with the table. It's a pretty good idea to have a lot of extra down travel on this, because if the table's uneven, it doesn't actually, you have no downforce on the pen at all. It's only the weight of the pen. So as you drop the pen, if the servo keeps moving underneath the slide carriage of the pen after it touches the table, that's good. This is how much room you have for the table to warp as the thing moves around, and the pen will stay in contact with the table. If you drop the pen down and the servo is only an inch below, or not an inch, but a millimeter below, or even still in contact with the slide when it touches the table, when the chassis moves over a lower part of the table, the pen won't go any lower, and you'll have a blank spot like I was showing you before. If you want to account for that, you can have a big difference between the pen up and pen down states. All right. And then timing, we'll talk about in a little bit. I'm just going to fire this drawing off so that we have a, so that we have a box on the table and you guys can see. I didn't even set that low enough, but it'll shade it in. Okay, great. All right, so does everybody have an external text editor set up? Awesome. All right.
If you need help, just raise your hand. And there's no help.
So let's get on to the actual, TouchDesigner stuff. Yes. Inkscape, necessary evil. We just talked about that. I made a utility called AxeEscale. It's also on that gist. We'll talk about that in a little bit, but it's basically a piece of garbage Python code that checks what the scale of your SOP drawing is and what the extents of it are, and then scales it onto a piece of A4 or letter paper. The Axidraw can draw A4 size, so I prefer A4 because it's a little bit bigger. If you do get a chance to plot on this, just real quick, I want to ask you, be nice to the plotter. You can't move the motors while they're on, so you do need to give it a command that's going to tell it to disable the motors, and maybe we can talk about that in a little bit, and you send it to home, and you're always going to print from the home position. It doesn't know where it is if you start it from somewhere else, and it can try to travel past its extents and strip the belt and stuff like that, so be nice. Okay. You're going to save often. You're going to find yourself saving a lot in the external text editor because we're going to be working in Python for the most part. That does not save your TouchDesigner project. So if TouchDesigner goes down, which it will, because we're going to be doing things that have recursion and things like that, or just simply you're going to be passing in arguments that dictate how many points to draw, you're going to accidentally draw things that have, 30,000 vertices, and your computer's just going to go down for a little nap. So my suggestion, when you save in Sublime or whatever external text editor you're using, also save in TouchDesigner. Just get into that habit. Look for that asterisk up in the menu bar. I crash it all the time when I'm working on this stuff. Okay, so CopyStop. I'm going to start a blank project with you guys in a second, but the CopyStop stuff, I never remember how it works. So I believe I haven't. Did somebody raise a hand? Please shout out questions, interrupt me if anything is wrong, which it probably will be. Especially when I'm doing this kind of stuff. You let me know if you see something funny. Okay, so what we're going to do here is we're going to drop a CopyStop. And I'm just going to show you like a functionality that we're kind of replicating because a lot of this stuff is already built into Touch. So CopyStop, counterintuitively to me, the template for the CopyStop is in the bottom input. So I'm going to give it this grid here, and it's a 20 by 20. I really don't care. So I've got a copy and I've got a grid. And I'm going to throw the grid into the bottom. This is the template for what the CopyStop is going to copy. Now, if I want to copy something just simply, I'm just going to give it, let's say, a circle. So I've got a circle and I've got a grid, and I'm going to throw the circle into the top input, and boom, now I have a grid of circles. That doesn't look so great. So I'm going to drop my radius down quite a lot. I don't know how much. We're going to go even further. Until, okay, there we go. Now we got a grid of circles. Look at that. And let's make them open circles because it just looks more like what the drawing's going to look like. Look at that. All right. Not that exciting, right? So what we're going to do is we're going to do a stamp. And what the stamp lets you do is it lets you pass knowledge that the CopyStop has further down in the SOP context back up the stream to other SOPs upstream of it. This is an idiosyncratic thing, I think, in TouchDesigner that is not super intuitive to me even when I work with it. The idea that typically we're in SOP world, we're building geometry, we're attaching attributes to it, and we're passing it down the chain to do operations on it procedurally, right? And then we're always headed in one direction all the way down to the render, unless, of course, we loop back. But this is a situation in which we're using knowledge about the context in the CopyStop to tell SOPs further upstream what we know later on. That might not make sense, but I'm going to show you in a second. And also, it's also like we're normally thinking in TouchDesigner of like a one-to-one kind of thing, right? So I've made one circle, and I'm passing that one circle into the CopyStop. But what we're actually going to be doing is acting as though we've made a circle for every, we've already done that, a circle for every point on the input geometry, right? But we're going to make different circles for every point on the input geometry. So if I pop up the CopyStop documentation, this is always a good way to go. Oh, wow, it's really quick. I'm very impressed. And we go down here. Believe it or not, these are in TScript. Are these in Python yet? Does anybody know this?
Yeah, there is.
Do you know where they are? Okay, if you haven't used TScript before, this is your chance. TScript predated Python as the lingua franca of TouchDesigner. And you see the swirly up here? This is the Python symbol.
Actually, if you go to the Python help for this, you know what I mean? Yeah.
Are you going to tell me something that's going to shatter my mind right now?
Up higher, right?
Huh? Huh? Huh?
Over there, there's
What?
copy.
Copy index. Oh, okay. Is that all? That's all I need, really, I think. Number of copies. Current, well, not exactly. Because I do, wait, I copy index, input point, current point. I need the I think I might need the number of points. Let me see what I'm actually going to work with.
What about the help function in the text port? There's sometimes more information than in the wiki.
I'm excited. Wait, do you say man? What do I do?
I thought it was just help and then like parentheses and then you put in like CopyStop. I think
Oh my gosh, landed. Love it.
Well, it was actually Malcolm that told me once.
I love this stuff. This is why I flew to Berlin. Wow.
But I mean, there might not be more, but sometimes there's more. Yeah, there you go.
Well, these are all SOP specific. Let me see if I can find anything CopyStop specific. This is storage. Storage. Viewers. This is Python op stuff. Here we go. Hey. Does this, wow. So, but these are Python
Those
concepts.
are regular ones, yeah.
Oh, okay. Here we go. Yeah, it's these again.
Same one.
Right. Well, I don't think I need all of these examples. Let me see which ones I actually used. I used, oh yeah, number of point, copy number, total number of points, which we don't have. All right, so unfortunately we got to do this in TScript. So what we're trying to do, and I'm going to show you a finished copy of this here, is we're going to be making the circle draw an arc percentage. And if I switch this back to just an argument here, I'm going to show you, if you're not familiar with this property of the circle, that you can draw, let me switch to 10 so you can really see. You can draw only part of a circle. So you can see over here I'm drawing the entire circle, not very exciting again. But what I'm going to do is I'm going to put in an argument in the circle context, and we'll come back to this, you don't have to do this right now, where we're going to extract a number that we're going to create that's going to tell the circle where it is in this grid. And the way we're going to do that, we need two things. We need to know what the instance number of the circle is across the entire grid, and we need to know how many there are in total. Right? So here we go. We're turning on stamp inputs. What we can do is we can make up attributes for the SOP context that are going to get passed back up the chain. So I'm going to call this one inst for instance, right? And what this is, I guess I can get rid of this here. I'm going to go back to the, so yeah, you want to switch to TScript here. So right here, whoops, see the pipe? That's kind of hard to see, but where it says language, you're going to switch to TScript. Maybe I should get a chair. What do you think? Where's I'm moving the guy? Okay. Hey, I like it. Okay. So once we're in TScript, we can type in this TScript stuff, which is going to look like a foreign program to you. But we have access to all these properties. I'm going to make this a little bigger for you. We have access to all these properties here about the CopyStop specific context. So we have the copy number, and this tells us, if we go back to the copy context here, we have this grid, and I'm going to switch this. I'm going to hit A, and I'm going to hit W, and you can see the wireframe here. If I wanted, I could turn on points, which is helpful as well. And so at each one of these points, we're making a circle. If I were to pass, actually, we're only making one copy, so that number is always going to be 1. But if I made another one of these, and I'll just show you what the number copy thing looks like. Oops, copy. If I made something that was, let's say, a triangle, circle, I'm going to drop another circle. I'm going to drop 2 circles. 1, 2, and one of them, again, is just the same circle we've been working with, but I'm going to call this one 3. And the reason I'm doing this is because it gets me 3 points here. There we go. Okay, I got my 3 points, and you can see your point numbers too, so you can tell what order it's going to do them. That may come into play as well. 0, 1, 2. Okay. This is going to be my template. This is going to be my drawing. And again, I'll drop the radius on this thing way, way down. I'm going to do it big first and then small. All right, good. And then I can actually increase the number of copies. Now, this is not what we're doing just for this other example, but I just want to show this to you. If I were to make, let's say, 10 copies, they're all going to be right on top of each other. So if I look here, I have 30 primitives. So that's not super helpful or exciting. But I could translate them by, I don't know, like 0.5, and there you go, that's fun. All right, so now when I've done that, if I go in here, I turn on stamp inputs, and I say copy, and then I say $NCY. No, that's the number of copies. I think it's just $CY. Oh, you hate me, right? But aha, okay. This number will mean nothing to you. It's displaying the maximum number that's being passed up the chain. But again, this is an idiosyncratic thing, I think, in TouchDesigner. But this value depends, is going to be different. This stamped attribute is going to be different for each of the copies being created. And we can do it for each of the points. We can do it for each of the... there's a couple, I'm blanking on the other one. We'll get to that in a second. Okay, so what we can do is here we can say, I think it's fetch stamp, and then the name of the, what did I say, copy? And then you can give it a default value, which I'll say 0. Yep, and then let me do it on both of these here. So you guys all got that fetch stamp and the name of the attribute that you just created. Whoopsie daisy. Huh. I guess the number gets pretty big, doesn't it? Well, let's space them out a little bit so we can actually see what's going on. No? 1,000? Oh, right. These are too close together. Okay. So let me just get this. I'm going to make the triangle quite a bit bigger. You know what's an easier way to do this? You guys don't have to make exactly what I'm making here. I'm just trying to show you an idea. I'm going to multiply this by like 0.01 so we can see what the heck's going on. And this one is not going to result in an exciting drawing. I'm just trying to show you the property here. Scale this back down. Oh, that's the number of copies. That doesn't matter. Scale this back down. There we go. Closer and closer together. Yes. Closer and closer. Look at that. That's kind of fun, isn't it? And then if I switch this to wireframe, well, you can't tell. There's a billion of them. But so that's the principle that we're working with here. What we're doing is we're sending information that the CopyStop knows that the circle doesn't know, and we're telling anybody back upstream in this SOP stream, like if I were to connect something even further up here, this information is in there. I honestly don't even know how to inspect it. Is there a way to inspect it or anything like that? It's only fetch stamp, right? Or no, yeah. So this is very idiosyncratic. Okay, so I love how I'm mystified by this. So in the CopyStop, we can access these different things about the copy parameter. Now, those of you who are interested in particle systems, we're not going to talk about this just now, but you can access these things that are normally associated with particles, like the age of a particle, the overall life of the particle. So the ratio of the age to the life could be used to make an easing curve that makes the particle get bigger, start at 0 size and get bigger and then die smaller again so that you don't just see it blip off when it dies, right? Now, doing particle systems in the particle SOP, is not super performant, and this is going to give you an even bigger performance hit. But if you want to do things in non-real time or something like that, this is a really good way to get access to this stuff and not have to write a whole bunch of GL code. Okay, so what we want to do with this, and these are interesting too, you can get at the centroid of the geometry or the bounding box around all the geometry that you've created and stuff like that. But what we want to do, just for the purposes of making this cute little circle grid that we made over here, is we're going to make a parameter called inst, and this is to get at the instance. I wonder if that ID, let's see if ID is the exact same thing, because that would be embarrassing. Let's see. Nope, okay. So we're going to make one called inst. This is for instance. And the quantity, this is the number of points, the total number of points times the number of the copy, and I'll talk about what this is in a second, plus the point. So this is a calculation that tells us where we are in a grid. And the reason that works is the number of the copy, what we're copying here, we've only got one copy, I believe. All right, let's do this another way. Here we go. So we're going to go back to our grid, and I'll make mine like yours here, or we can do one together. Grid.
Noah, can you make the resolution on the projector
Is it too small?
less? Yeah, so it blows everything up.
Yeah. Yeah, or maybe, yeah, otherwise I'd have to do DPI scaling in Windows, right?
Yeah,
Let me do that.
The res, drop it.
I hope that doesn't mess the recording up. Let's find out. 720, let's go to 720. Oh, hey, that worked. Is that better, everybody? Okay. All right. So I'm just doing the same thing we just did again in a second, but I do just want to cover what TouchDesigner does natively. Okay, so again, my circle's going into the top input, my grid's going in here. I'm going to scale my circle down a whole bunch so that I don't have to deal with them overlapping too much. I don't know. Numbers not magic, something like that. Okay, great. And I'm going to make this grid actually be 20 columns, but one row. And this should be homing. Hello? Oh, yeah, there it is. Okay, so I just have this one row now. And again, if I go over here, I should see, yep, as I expect, I got a bunch of circles. Boy, this is claustrophobic. And I can't make my text board any smaller. I guess I'll put the text board on the bottom. Oh my gosh. Alt-Z. You guys should probably pop your text board open for what we're about to do next anyway. So if you want to do what I just did, it's Alt and then the right square bracket. And then you can hit Alt-9 or you can just pick a text board here. I don't think I have room to do this though. Okay. Great. Okay. So again, this is the, you guys probably already did this, but we're saying the number of point times the number of the copy, the number of total points times the number of the copy plus the number of points. And I'll show you what I mean by that. So here, I'm going to make 20 copies, let's say. And they're, again, all sitting on top of each other, but we know that they're there because we have 400, 20 by 20. And I'm going to translate in the Y by, I don't know, like 1. Or no, it's pretty small, isn't it? Like 0.1. Yeah. What was the radius of our circle? 0.03. That's quite small. Let's do that. 0.03. Okay. Is it double the radius? Yeah, 0.6. Naturally. Okay. And so what we're doing with that expression is we're saying, I want to know where I am in the grid. So the copies are going vertically. So the copies are 0 through 19. The total number of points that we just did, this total number of points, is the number of points in the templates. That's 20, right? And then this point number attribute is which point we are from the template grid. And if I go here and I hit A, and then I hit, I right click and hit display options, I can show point numbers and show points. And you'll see, oh wait, this thing's going vertical? Did I do that? I thought I said one column. Oh yeah, I did. Okay, that doesn't matter. All right. So you can see that these are numbered, right? So I'm trying to figure out which one I'm at in here. And this calculation is going to tell me exactly that. It's the number of points in the grid, which is 20, times the number of the copy. So that's going to be from 0 to 19. And then we're going to add in 0 to 19 to catch where we are in that last column, right? And so that number is getting passed back up the chain to the circle SOP, and now we can access that. And what I like to do to make that drawing here is I'm going to say, and then we're working in Python again here, so depending on what happens, sometimes if you've switched another node to TScript and then you create a new node, it'll still be in TScript, so you just want to make sure you're in Python here on the language setting, right? So we're going to say fetch stamp with a capital S, stamp, And then we call that inst, that's the instance, right? And you got to give it a default value, doesn't matter what it is because it's already there, but just say 0. If you don't, you'll get an error. That's not going to make any sense, right? But what we want to do is we want to scale that back down to a range that makes sense. So if I look at what I've done here, because I can't honestly remember, I multiplied it by 360. So that's going to be the total size of the circle. And then I'm accessing another parameter here. And the other parameter that I've created is how many do I have overall. So that's going to be the number of points in the template times the number of copies that I've elected to make. And the number of points, again, in the template is coming from here. There's 20 points in my template. But the number of copies is dictated by here, the number of copies in CY, and the same thing in Python. Oh no, I see that we're in TScript, right? Okay, is the par that I've set. Gosh, that's hard to do. There we go. So the number of points times the number of copies is going to be the quantity 400, and we're doing this so that we can change these on the fly, right? So, is this the one we were working on? Huh? Are we working on this one? Did I just not do it? Wild. All right. Whoopsie daisy. So I'm just going to grab this. That's my inst. And I'm going to switch to TScript. I'm going to do what you guys just did. Great. And then I think I called it copy, right? And that's our number of points, NPT, times our number of copies. And that should be NCY. Great. So you can see that the maximum value of our instances is going up to 399, and the maximum value of this copy quantity, which actually is not changing from point to point going back up where we're accessing it, is 400. This is static unless I change the template size, adding more points to my grid here, or if I change what I'm feeding into it at all, or if I change the number of copies here in the CopyStop. I'm not going to do that just so we can see what we're doing here. So then we've created half of this thing, and I believe what I did was I just divided by, again, fetch stamp, fetch stamp, copy. And then I'll give it a default argument again. I didn't like that. It's Atsamata for you. Oh, divide by 0. Yep, because, actually, no, I don't know why this error occurs, to be honest with you. And I banged my head against this for a while getting ready for this, but I just added 1 to that. And then there you go. Right? Does everybody see something like that? Or more importantly, does that make sense? Does anybody have any questions about that? Sure, totally. Yeah. Absolutely. Okay, so in order to calculate the instance number, going from 0, here you can see it counting up, going up all the way up to instance number 400. We're counting from 0 to 399, really. This quantity, NPT, let's go to the documentation here, is the total number of points in the template. And the template is the grid that, how do I not? I have no doc now. In the template. And the template here is this guy, so that's going to be the number 20. I'm middle clicking here. Right? And then, I'll go back over here. So what we're doing is we're saying 20 by this is actually what you would call in GL as a varying, right? So this is going to change depending on the context in which I ask for this quantity, right? So on the first row, on row 0 here, the number of the copy is 0. On this row, it's 1, and on this row, it's 19. Because what we're doing is we're taking this grid and we're moving it up by 0.06 from the bottom up 20 times, right? So by the time we get to the top one, we're at number 19, all right? And then those two multiplied by each other will tell us how many points are up to the row before where I'm at right now. So if I'm trying to, I probably shouldn't point because there's a recording, right? Okay, I'll use the mouse. When I get to here, this quantity is 19. I'm sorry, no, it's 39 because there's 20 in a row and they're 0 ordinal, right? So this is 39. All the way across the next row, this quantity right here is still 39 because we're calculating the number of points times the number of the copy, and it's 0 ordinal again, right? So this row counts for the number of the copy here is 0. And when we do this calculation on the first row, we're adding in the number of the point in the template that we're executing, right? So it's 0, 1, 2, 3, 4, 5, 6, 7, all the way up to 19 here. That's this quantity. And then in the second row, the number of the copy becomes 1, right? So then this one gets the total number of points again in a row, which is 19, times 1. So this quantity becomes 19 at the beginning of this row, plus the number of the point in the row, which again is 0 through 19. If I made these 10s, this might be a little clearer. So let me just do that so I can 10, and then 10. So we're not doing 20s math. We have 10 fingers. Okay. Right? So again, just to inspect that one more time. Oopsie daisy. Can I see both at once? Is that too much to ask? What are we dealing with? Okay. 0 through 9, right? This quantity will be 9 in the second row. It's 0 in the first row. It's 9 here, right? It's, what is that? 19 here. And then the number of the point in the template that we're executing. Does that make sense? So when we add all those up, we get what number we're at in the grid traversing this way in this instance. Does that make sense?
It'll be 10 on the second.
0 through 9, right?
Right, so on the second row, then the end point, the first inside the brackets, that's going to be 10, right?
The number of points. Yeah, you're right. You're totally right. Thank you. Of course, because then we would lose one every row. What Malcolm said. And then the second thing that we want to know is we just want to know out of how many. Because what we're doing is we're building up a fraction. For every one of these, we want to know what fraction of the way through this are we. And if anybody's done any GL programming, this is something you're constantly doing, is like figuring out a progress bar, right? And we're just animating a progress bar here. If we were doing this on a single circle, we could maybe make this a time modulo something else, and it would be counting from, or divided by something else, and we would be counting from 0 to 1 over and over again, and maybe multiplying that by 360 in order to make the circle spin like a clock. We're doing that same thing, but like a zoetrope here, right? So we're saying, what number am I out of how many? So this is going to be 0, and this is going to be 99 out of 100. And you can see that it's 99. It's not totally finished. If we were to add 1 over here, we would never get one that's nothing, but we would finish the last one. So if I add 1, and I would open a GeoViewer, but it's just too much. But you can see that now we're finished, right? But then we don't get we have one that has a little speck instead of a 0. Aesthetic call, not important. Does that make sense?
Yeah.
Okay. I'm sorry if that came across a little scattered. As I said, I don't know a ton about SOPs. Let's get on to the stuff.
Can
Yes.
you just show that expression on the other?
Oh, sure, yeah. On the circle, the math that we're doing is, and I could move this, if I move this 360, this will be a little clearer, like what's actually happening here. Right? Order of operations. Yes, okay. What we're saying is, what instance are we? We're building this fraction here, and I'll get rid of white space just to make this clearer. And actually, I'll show you a little trick. If I'm in this context and I hit Control E, it will, oh, it opened over here. It'll open my, hello? It'll open, goodness gracious, my external text editor, and I can edit this expression in an external text editor, which is pretty sweet, especially when we're working at low res. So, this is what is our instance number. This is how many copies there are, and maybe I could have given this a better name, like total copies or something, right? And this is going to come up to a fraction. Why did I add 1 down here? Because you get an error if you don't. It says that you're dividing by 0, even though that value is never 0. There's probably a better way to do that. I honestly don't know what it is. It strikes me as a bug.
Initialize it not with a 0?
Yeah, that's a good question. Let's try that. I think I tried that. Save that. Let's go back to TouchDesigner. Hello? Yeah, error. Divide by 0. Isn't that odd? I should report that. Okay. So I'm just going to add 1 here because it's banging my head against this is the only fix I could find at the time. So if I call this total copies, that'd probably be a better name. But we're saying how many are we into the grid divided by how many are there in total times 360 for the arc value here on the end angle, because 360 is a complete circle. just an example. You could do this with any parameter, anywhere up the SOP chain, anything. You can access these. There is no way to know that it is there. If you're used to inspecting SOP context by like dropping a SOP to DAT or something like that, you're out of luck because it's not there. It exists in this magical nether space that is specific to the CopyStop.
But it's accessible from any SOP in that network because it's in the complex.
Yeah, so you're dropping it in there. It's kind of an attribute, but because it's context specific, it's being executed. It's being evaluated in a context. There is no reasonable way to inspect it given the interface the TouchDesigner offers you. Even including, you can see here that this value would normally be the result of the computation of the expression, and they have to put something there. So what they have is the last execution of that counting up, which makes sense. But it's just it's a funny TouchDesigner specific thing. So this is a really cool way to do the type of drawing that plotters are really good at because they're mega precise and they can express just, I mean, there's not that much to this, but like, that's cool. Like if you plot that with a nice pen on a nice piece of paper, people are like, shit, that looks 1,000 times cooler than it does on the screen. So one of the things you start thinking about with the plotter is like you have a certain thickness to the pen, you have a certain texture from the paper, you have a certain artifact that comes from drawing on paper. The stuff that you're used to in pixels is not necessarily remotely compelling or possible in the context of a plotter. But the stuff that may be a little humdrum, just in terms of just changing one little thing and repeating it over and over and over again, is actually pretty compelling when you see it in a physical space. The precision of it, mixed with the kind of imprecision of the pen, is really aesthetically pleasing. All right, so let's start talking about the script SOP context. And I think what I'm going to do is I'm going to claw this thing back over to my screen, and I'm going to start a new project alongside you guys. So let me just get another window up here, and because I just want to make sure that we're all doing the same thing at the same time. Is that thing in focus? Is that working okay? Okay. I'm opening another instance of TouchDesigner. So in the script SOP, you have access, and the model SOP, you have access to everything that TouchDesigner knows about SOPs and everything that TouchDesigner can do in SOP space. That it's still loading these things. Let me just get rid of this. That's tomorrow. Okay. All right. Let me drop this guy. Boom. Okay. So what we're going to do, we're going to drop a script SOP.
Yo, Noah, can you bring up the long expression from the last one?
Certainly.
Circle SOP?
Oh, did I close Sublime? Yeah, give me one moment. So here we go one more time. You guys got a problem?
Can you control mouse wheel?
Does that work? Control and mouse wheel? Hey, look at that.
Why you add one here?
Yeah, you add one here because if you don't, you get an error.
No, this is another.
Oh, I'm sorry.
There is no. No, still the same. It's very strange.
Is there something I can help with?
Here it's first it's here.
So I always got this.
Oh, that's cool. Wow.
Yeah, we get it.
Wow, that's fun. So, touchstamp, yep, the instance divided by copy, yep, that's totally right. So can you show me where you're creating that value? So can you click on your, yep. Show your stamp. Yeah. The number of points times the number of the copy plus the number of the point. The number of the point times the
Not NCY, but CY.
CY.
There's a change in it.
What? What'd you call that parameter? But you didn't give it a name.
Oh, what
Copy.
I think that is CY.
It's NCY.
What a fun mistake that was. I wonder if I can replicate it. Did that work? Oh, great. Okay. That was really cool. Are you guys okay? That was very cool. We got like a spider graph thing going on. Okay. Let me get rid of this. So we're dropping a script sop. So we're going to do something. This is just a stylistic thing that I like to do with script sops. And let me call up my my thing and make sure we're going in order here. Yep. Okay. Simplifying geo for plotting. Oh, this is a special request from Isabel. So I'm just going to show you this real quick. There's a piece of geometry that you can't get because it's large and it's in STL format, which is a pain to convert. But I just want to show you a quick. And again, I'm not a sopsman, but hi. How are we doing? Whoop, there we go. All right. Okay. I loaded a piece of geometry in the file in, and I've just created. I don't even know that this is useful, but again, by special request, this is a piece of the moon that was scanned by NASA. NASA has a. I believe it's on the gist. Can I have it? I'll have to put this on the gist. NASA has some free geometry that's fun. Oh, I see. I put it on this because I converted it to an OBJ so you can load it. But as it is, when it comes in, it's quite big. 737,000 vertices. If you try to open that in Inkscape, if you just dump that out through SOP to SVG, try to open that in Inkscape, you're essentially crashed. Your computer would take weeks. I don't care what kind of computer you have. Inkscape's just not optimized for this kind of stuff, all right? So the first thing I did is I just dropped out like half of the polys. I'm doing a carve to extract the middle section of this thing. I'm just taking like a slice out of it, right? And then I'm getting rid of a whole bunch of stuff from the bottom, so I only see the top layer. And again, this is not, I don't want to dive too much into the procedural geometry stuff, but I'm slicing off everything below the very surface of it so that I get holes where the craters are, because otherwise I don't want to draw in all the polys in the crater. I'm going to have triangles everywhere. And then I'm reducing the number of polys one more time, and what I get is a more manageable 600,000 vertices. And this stuff right here, which I believe I had in the intro to the presentation, but it didn't load all the way. I don't know that it's a good idea that we go through all this stuff real quick, but basically you can totally plot geometry, but what you want to do is go through a SOP network that's going to simplify your geometry in an aesthetically pleasing way. And one of the ways that I found to do that is a combination of poly reducing and slicing, because the original geometry, if I go over here and look at this, is actually quite serious. You can see it has depth, it has a finished bottom, it actually has a thickness to it. If I switch to wireframe, you'll see that there's a, boy, it doesn't like doing that. There we go. Am I already on wireframe? It's just so complex. Oh, I'm sorry. It's so dense that, like, if you drew this with a pen, it would just all be black anyway, right? So, if you could get it to do that. So, if you're going to work with geometry that has a lot going on, you're going to want to reduce it in a way, and by making some decisions, especially like this is probably the most relevant decision, is I've used the, boy, I'm tumbling. I've used the delete SOP here to make a bounding box that is, a little bit bigger in the XY plane than the geometry, and has some Z depth that's big enough for me to scooch it up just enough to like shear off everything except the very top layer of this. And you'll see if I scooch this up, and I'm killing more and more and more of it, and you're getting this kind of cool eroded look, which is moody and fun when I go and print that, right? Look at it go. Okay, so that was by special request. Isabel, I will go through that with you again at another point. Okay, so let's talk about ScriptSop. I have another instance of TouchDesigner open here. So the ScriptSop, in the ScriptSop, like the other script ops, you can create custom parameters that you can pass in arguments with, and you can execute Python code on every cook. So if I hit Control E here, I can get up my, oh boy, this is going to be fun. I was planning on doing, oh right. Can you still see if I make it that small? Hi, Isabel. I was just talking about you. Your ears burning. Can you still see in the back? Is it okay if I make it a little smaller? How's that? Tell me if it's not. Okay, all right. So if you want to get two columns in this, which I would recommend that you do, you go to View, Layout, Columns 2, or you can hit Alt-Shift-2. I like to put my ScriptSop callbacks on the right column, and then I like to make for myself a library of drawing tools that I can, let's say, save to an external file and check into a GitHub repo, access in other projects, things like that. I'm going to call mine NNDraw. You can call it whatever you want. And I'm going to open this guy, and that's going to open up over here. What this is going to let us do is tell the ScriptSop what to do on every cook over here. Do some stuff. And every cook, I can tell the ScriptSop what to do. And then over here, I can build up a library of drawing functions. And what we're going to do over the next 2 hours 45 is get as advanced as we can. We're going to start with really simple primitives. We're going to abstract away some of the stuff that the ScriptSop does natively so that we can handle it in ways that are more functional for drawing. And then we're going to actually do drawings if we can. Yeah?
Sorry, how did you open a text editor?
Alt-E is the shortcut to open a text editor. It also works for parse. If you haven't assigned your external text editor in your preferences, that could be why that didn't work. So if you go in here, you're going to go to Edit, Preferences, or hit Alt-P. Whoops. Again, it's my primary screen. And then if you go to DATS here, and then you're going to set your text editor, and if you like your table editor, you can make Excel your table editor or whatever you want to do, right here.
It looks like the shortcut's Control E now.
Oh, I'm sorry, yeah, Control E. That's why it's not working. It was Alt E in the beta, right? Briefly? Yeah, I'm sorry. Control E. Shift Alt 2, I believe. But there, if you want to find it, it's under View, Layout, Columns. That's huge. Massive. You can actually do a 4-up and all kinds of stuff. So do you guys have this set? And it's Control E. Did you hear me? I'm sorry. Control E. Yeah, I'm sorry. I had old information for you. Everybody good? Yeah? Okay. No? Here, let me help. No. You're going to do it on the text. Control. Yeah. Okay. All right. So let me just show you a quick. Everybody good? Here we go. I'm going to show you a quick example of the ScriptSop. I'm going to try to do what Stan does so well. If you guys have taken Stan's tutorials, which I really recommend, Stan's classes, he builds up things function by function, so you can actually see how they work. And I'm going to do my best to do that. I don't have nearly as much experience doing this stuff as he does. Stan Glazov? How do you pronounce his last name? Lichthad. I can't pronounce that either. I'll try to call up that link when we take a break. I'll show it to you. He has excellent TouchDesigner courses. Okay. So the first thing we're going to do, just as a kind of a hello world, and actually let's make this easier on ourselves. So these three functions, the boilerplate functions that come with every ScriptSop, are on setup parameters, which doesn't execute by itself. In order to get this to do its thing, you actually have to pulse a par. Here in the ScriptSop, you're going to hit setup parameters. It's not going to do anything right now because it's already set up. But what this does, like it does if you're making custom parameters for comp, or if you're making custom parameters on any of the script ops, this will let you create pars, any pars that you want, that are values that then you can access inside the context of the script op, right? So we're going to leave these for the moment. We'll come back and we'll make some for ourselves. You can also execute some other stuff here, right? And then every cook, all this stuff gets executed. So the first thing you're going to do is clear the script op context. I would not remove that if I were you, because it'll just begin to propagate the geometry. I'm not sure what you, well, I'm not sure why you wouldn't remove that. But let's just do ourselves a favor here and hit change script op to SO, because we're going to type it 1,000 times. So if you just save that out and you go back to TouchDesigner, you're going to make sure that you didn't break anything. We didn't. We're looking good. Okay. So the first thing we're going to do is we're just going to copy the input geometry. So we're going to say script op copy. And we're telling the script op to do its built-in copy command. And we're going to tell it from your input array, because it has an array of inputs, you can connect multiple things to it, copy what's in input 0. And what that does is, what's your problem? No input.
Inputs.
Oh, thank you so much. Did it anyway. It gamely complied. So now we can see that we have the exact same thing from this circle over here. That's a very, very simple script op maneuver. Okay? We did that. Talked about that a little bit. We're going to add some things. I guess I have 2 of those. Oh, yeah. The thing that we're working with in the context of all of our SOPs is... nuts. I should have installed... I'm booted off the network. I suppose we probably all are. Connect automatically. I do want to show you... it's another thing I learned from Stan, is always show the documentation. Show your work. All right, I think I'm connected. Reconnecting. Well, I have this here. Let me see if I can get to... what was I doing? Oh, yeah, the structure of a SOP. Well, we could just talk about it. Okay. So all SOPs have, within them, primitives containing vertices. Let's drop a dat here. So we're going to drop a SOP2 dat, and we're going to take a look at what's inside of our script SOP. This is probably a good idea to have around at all times, just so you can see what's going on. And you can inspect the contents of your SOP. Let's just drop the number of points here on our circle to 3, just so we have less to deal with. Okay, great. You can see that in our circle, which is actually a triangle, we have 3 points. Those points have positions associated with them. They have normals, right? If I go and I look, I have 3 vertices. Oh, I'm sorry, I have 3 vertices, and the vertices have UV values associated with them. This is if we were going to do some texturing and rendering and things like that. And there is one primitive that has the vertices in order 0, 1, 2, and it's closed. And if I go and make this an open, archetype open, you can see now I have an open primitive. Okay, so this is a great way to look through what's inside of your SOP. And what we're going to be doing in the context of the script SOP is creating and moving these things around. Largely what we're going to be doing is making polys that have points contained within them, and then we're going to change the positions of those points, normally in that order. Okay? Hopefully this is still up. Yes. Okay. Reusable tools is the name of the game. What we're going to do is we're going to take the whoopsie daisy. We're going to take the built-in stuff that's in the script SOP, and we're going to abstract it a little bit so that we can talk about it in ways that are a little more amenable to drawing. And let me just grab this and pull my secrets over to my display here, because we're going to make these things together. So the first thing we did was copy this. Now, what I would recommend is somewhere in here, you're going to say import, and I called mine NN draw. I don't know what you called yours. If you called it mine, I'm flattered, but feel free to call it your own initials. And I'm going to say as DRW. So what this did was it let us reach anything that's in this context. So this is the other text file that I had here. Whoops, didn't like that. What did I do wrong? I don't have a text port. Hang on. Module compilation error. Did I misspell and then draw? Hello? I think that's right. It seems I have a context problem here. Let's see what this guy has to say about it. Yeah. Uh-huh. Actually don't know what the problem is there. And then draw. Module compilation error. Maybe it's because there's nothing in there? That seems odd. Sorry, this two monitor thing is really throwing me for a loop. There you go. Uh-huh. Wait. What is that? Get out of here. I should have, oh yeah, blank.
Try, just typing the import command into the text port. Sometimes that fixes weird
Okay,
stuff.
I like that. Import, and then draw as, whoops, just that. Let's just try that. Yeah. How odd. Is there a typo here? Hello? Maybe it's not seeing this as a module because it doesn't have any Python in it. Yeah,
TextStat doesn't have
yeah,
text.
yeah. Let's try that. It's probably not even. Can I just open this? Is that too much to ask? There we go.
Yeah, it's just
What's over here? One more time with feeling. Oop. So, oh my gosh, this two monitor stuff, you guys. There we go. Can I? Yes. And this, you can drag tabs from window to window like so. Whoops. You can just get it to the top. Boom. Okay. So this is where you guys were a moment ago. Let me just say def test colon pass. Let me just see if that fixes our issue here. Yes. Okay. Well, we learned something new today. How persnickety. You guys don't need to do that. We're going to create a method right now. Okay. So the first thing we did was copy, and we're probably going to do that again. So let's just cut this, right? And we're just going to drop it in place of this, and we're going to call this guy copy. And if you really want to make this useful, we'll say input as an argument, and we'll default it to 0. Do you guys know about keyword arguments here and default values in Python? Just so you know. Is that a reserved word? Uh-oh. Let's call it imp. Imp. Yep. Imp. Okay, great. In Python, you can give arguments a default value, and that way if you don't provide any arguments, so let's go over here, I'm going to say DRW, that's because we imported our new module here as DRW. DRW copy, and I'm not going to give it any arguments. Save. What is it with you? Huh? Script up. Ah, yes, thank you so much. And we're going to have to do this for every one of our methods is going to have to get passed in the script op. Because we are passing our first and only command here to the script op. We're telling the script op to copy from the script op's inputs. And we need to be specific about which script op. So all of your built-in arguments or built-in functions in the script sop have the script op passed in. This is kind of like working in a class, how you get self as the first argument to all of your class member methods. That is because we're executing this in an unknown context, and we want to make sure that we're referring to the right script op. So we're going to have to pass that by reference, right? So we have the script op here passed in, and we're going to copy its input, and we have a default input of 0. That makes sense? All right. First method, and it works. Excellent. Okay.
We have that working.
What was that? Is it, yeah, does everybody have that working?
Raise your hand.
Okay, let's break for a second. Catch up.
Oops. Sure. Oh my gosh. There you go. Is this too small for you? That better?
Yeah, leave that up for a sec.
I see an error over there. Do you need help? Sir? You okay? You all right? Okay. Somebody leave a water up here?
I brought the Steve.
Did you? You were so sweet. Thank you. It does say bad on it, though.
I said it's a teaspoon.
Oh.
You have to save both.
To save this stuff, it's
And guys, please feel free to speak up if you're stuck on anything. Really. We got 4 hours. It's fine. Don't suffer in silence. Excellent. Middle click on your script stop. Let's find out. Oh, I see. I think alt right click. Just try it. No. Yeah, you try alt right click. Yeah. Cool. Model compilation. Okay. Oh, you didn't create a. Oh, you did. Oh, okay. Okay.
That's good. So
Did you save it?
So when you reopen that one,
No, that's in TouchDesigner's code. Yeah. It should be. Yeah, it's important. It sees it. A middle click on that. Oh, I see. You need a colon. Yeah, so go on back over there. And then put a colon right after the close part. First line. Right there. Yep. Really good? Okay.
And for instance, here we import this. So we are now in script.
Don't worry about the socks.
Yeah, but what I want to do is now we have this and I import it. And I don't have to define in that case that it's an operator. It knows that, oh, it's called Axidraw, so I would import
Yes,
it.
yes.
So it's
The
not-
module system in TouchDesigner looks for a text tag by that name and will import it as a Python module.
Okay.
Mm-hmm.
Well, because so far when I created a module, it was like it was very specific.
Yeah,
Like it has to name modules. And
yeah. It doesn't.
not okay. Cool. I didn't know that shit.
Yeah, yeah. So you can throw Python around willy nilly like that. You can really you don't want to be messy about it. You should have some rhyme and reason. But this is a really easy way to make reusable Python code accessible all over. It's context specific though. Like I don't think it. I'm not sure about this, but I don't think the namespace will work if this is not in the same level.
Yeah, that's what I was
I'm not sure.
I cannot.
I should know that.
If I go out, then you cannot really access it here.
I don't think so.
Okay, so
I'm not
what
sure.
is-
Try it out. I mean, it works in the text board, so it might.
Okay. I'll just take it easy now.
Yeah.
I think it's
I actually kind of need to touch designer myself, so I don't really know too much about that kind of stuff. How are we doing, guys? Yeah, of course. Yeah, go ahead and middle click on it. Oh, okay. Go back to your. Oh, you got it right there. Oh, you got it in text form. Okay, great. Save. Save the letter, you know.
we have a triangle.
Yeah.
I'm curious about this Google.
Yeah. We're making good time. I expected to spend 45 minutes installing all that stuff, so I'm glad we didn't do that. That was a bad idea.
Yeah, that's another. It seems like it's another part, you know, to get all of the what you said, depends on like all this thing you said with the virtual stuff. And I don't know.
Yeah, that's a
That
good.
would be cool.
It would be good. Another talk or a workshop or something maybe. It was foolish to think that we were going to do that together. How's everybody doing? Everybody on the same page? Please speak up if you have a problem. Really,
Yeah, if you
don't get
guys
left
raise
behind.
your hand, it will like come around.
That was probably the most likely place that you would have a problem from here on out. Okay, so we should be good now. Okay, let's write some Python. So, in a script shop, let's just comment this out. So if you're in Sublime, which most of you probably are, or other text editors work this way as well, you can hit Control/ to comment out a line. And then if you save again and just take a peep at TouchDesigner, you'll see that we have nothing back in our script shop. I can middle click and I can see we're back to a blank script shop. So I want to make a line, and I just want to show you really quick how to make a poly in a script shop context. We're going to say append poly, right? And then we have some arguments. In this case, let's say I'm going to give it 2 points. This is your first argument, and I should bring up this documentation, but I'm not connected to the internet. Gosh, I should have gotten that offline. Okay, we're going to say closed equals false, right? And you remember what closed was from the circle, right? It's the difference between having just the outline or calling it a closed poly, right? And then our third argument, we're going to say add points, and this is going to be true. I believe those are the defaults anyway, but we're just going to be explicit. So I'll go back to my script shop. Hey, look at that. It's a line. We made a primitive. It's a polygon. It has 2 vertices, and those 2 vertices have 2 point members, and those points have positions by default of 0, 0, 0 and 1, 0, 0. Just a quick note about 3D. I, wherever possible, have made this code 3-dimensional because late in the game, I knew this was going to happen. I figured out how to do perspective. And hopefully we're going to do that real quick before we get to the end of this. This is probably one of the most advanced things we're going to do here. It's not all that complicated, but it'll allow you to actually render flatten out to SVG with perspective out of the SOP context. Okay. So hey, we just added something. We just drew our first thing. And what would you call that? I would call it a line. So let's grab this. Control X is what I did. You can cut however you like. Def. And we're going to say line. We're going to, of course, pass in our script dot. And let's pass in an argument, number of points. Whoops, points. And we'll say 2. Don't forget the colon here. Colon, right? And then just paste in what we just did. And what we're going to do is we're going to replace that number 2 with our argument, num points. And save. So now, I by default will create a line with 2 points. So again, if you're seeing a pattern, this is good. We're going to draw a line, and we're just going to pass it the script dot. Does that make sense? And I believe, unless I got another funky error, hey, look at that. It looks exactly the same. So now we can do our writing over here and just call these methods functions. I'm using those words interchangeably, and they're not. I don't know which ones. Gotta be honest with you. We're going to do them over here in the onCook function that gets called on every cook. So just again to zoom out, on every cook, we're going to clear the context. If we didn't, we'd just be accumulating lines on every cook, and we would quickly blow up TouchDesigner. Speaking of which, save TouchDesigner, everybody. Save in TouchDesigner as well as in Sublime.
Also, what sometimes happens is you'll lose the link between Sublime and Touch, so you'll be saving constantly in Sublime and nothing's happening.
Oh,
Just close all your tabs and then go into Touch, right click and edit again so it opens up, because we just had that.
thanks, Verse. Plotter, Berlin, class time. Cool? Everybody on the same page? Great. I love it. Feel free to speak up, please. Shout it out. Okay. So now we have a line. I believe I had an example that was fun to do with that. Whoopsie daisy. Circle straight across. Boy. Wow, we jump right in with this stuff. I'm acting like somebody else wrote this.
Somehow share the Google Slides link,
Absolutely. Yeah.
like now.
Oh, I see. The Google Slides? Yeah, sure. It's going to be a really ugly URL. Oh, I don't have internet access. And I'm on the network. What did you disconnect and reconnect last time? Is that how it got back on the internet? I'm not sure how useful this is going to be because it doesn't have any code in it. It's just the kind of headlines of what we're about to do. But if I can get back on the internet, I'll share this in a second. Okay, so we're going to do a drawing. We're going to do our first drawing because that was just a line, right? We're going to do a doodle. I just got to find it somewhere. Oh, here we go. Okay, great. Oh, this is going to be fun. You guys, we're going to do all kinds of new stuff. All right, so let's do a drawing. And let's make ourselves a little comment here. Well, whoopsie daisy. We'll do 3 quotes, and we're going to say drawings, right? We're going to separate our tools from our drawings, or actually our basics. I don't know. Let's call this basics. Basics. Right? Nah. You can call it whatever you like. And here are our drawings down here. Okay, great. So we're gonna make a drawing called circle straight across. And we're going to pass in our script op. You can call it whatever you like, but it's probably a good idea to keep it called the same thing as mine. Let's give this a default argument. Okay. So what we're going to do, and let's just test this out as a little example here, is we're going to say, just as a little hello world here, we're just going to call line from this. So if we go over here, I'm going to comment this out. And again, this is the way I like to work. It's like control slash. Yeah. I like to work this way because what I'm doing is over in my script SOP, I have a history of all the drawings that I've done and all the tests that I've done. You see that on the right? Like this is going to become like my terminal history in a way. I can go back and if as I make more and more complex drawings that have a whole bunch of arguments and stuff like that, I have a history of exactly what that run of that drawing was. And I just keep commenting and they just go down and down. I'm really only doing one line of code in my script SOP, but over here I've got a bunch of tools built up and stuff like that, right? Okay, so I'm going to call my circle straight across. Circle, unfortunately in this IDE, it's not even an IDE, and in this text editor, you don't get completion on the functions from the other side, but let's just call this with 10. And we're going to save that, and we're going to save this. And let's just peep at TouchDesigner and make sure. Yep, look at that. Awesome. Okay, so I'll put this back up. Does that make sense?
Leave that up for a minute.
Sure. Now, yeah, this is what I'm going to try to do this by building up things that work rather than just typing out the whole function right away. Is everybody cool? Can't believe we're all plugged in at the same time. I'm amazed. We're on like 2 circuits.
We need another power plant or something.
Yeah. Yeah, burning a lot of coal. Anyone have questions? Anyone I can help out? No?
I just wonder when you code the line at the circle straight across, then you only get the script out, and you didn't define the number of lines as an argument.
Right, so that's, you see where it says num points equals 2?
Wait,
In the line, are you talking about the number of points in the line? Or you mean the number of lines? That function is very much not done.
okay.
We're just,
Okay,
we're going to build it up out of things that
I see,
work.
I see.
Yeah. I hope that's clear.
Mm.
I'm going to try to do this to like, I'm with you all the way away instead of just, we're just going to type like 10 lines and then hit save and hopefully it works.
Cool.
Everybody cool? You good, Burrs?
Yeah.
Okay, nice. Okay, so really simply, now we're calling our line from another function, and if you've gotten this far and you've hit save, look at that, we're back to just having a line. Boring right now. Here we go. So I want to add something to our line function. We're going to say return. Because the append poly method function, I'm just going to keep using those interchangeably until somebody corrects me, will return a reference to the poly that we just made. And we're going to need that. Okay? Right now we're throwing it out. We're calling this and we're not catching the return value, but we're going to do that by saying p equals. So now we have a reference to the poly that we just created. Nothing should change. If you got an error, you had a typo. Okay? Now I just want to show you really quick that p that came back is a poly, and the poly has vertices that it contains. And let's just go back to the script dat, or SOP2 dat, sorry. You can see that if I'm looking at my primitives, I have this one polygon has 2 vertices, vertices 0 and 1, right? Those vertices, 0 and 1, don't have a lot of information attached to them, but they each contain a point, and those points have a position. So we're going to need to drill down into our poly, into our vertices, into our points to get to the positions. Now, the poly contains the vertices in an array. So I'm referencing my poly, and I'm going to reference my first vertex by calling 0. This is vertex 1, number 0, right? That has a member named point. I'm drumming on the table like an idiot, I'm sorry. And then that point has a position which is a capital P. Now, currently, if I go back and I look at TouchDesigner, you don't have to, I'll just show you, because I know all the clicking back and forth is tough. There's a tuple in that position, which is 3 values x, y, z, and that first one should be 0, 0, 0. If I were to say change that to, you don't have to do this, I'm just going to do this real quick. I don't want to create too many opportunities for error here. I'm just going to change that to 10, 0, 0, and then, hey, that didn't work, because I didn't save. Save. I'm going to go back. That just straight up didn't work. Oh, no, it did. Of course. Foolish. How would you know? Because it's auto-homing. Let me just call it 10, 10, 0. All right. There we go. Look at that. I got a diagonal line. So I can change these position values by passing them, in the simplest, a tuple, a 3 tuple of x, y, z values. Okay? So now I have a reference to my first point, And I'm going to do the same thing. I'm just going to get a reference. You can copy paste if you want to avoid typo opportunities. And I'm just going to leave this at like 1, 1, 0, which is I think what it is right now. And I just want to make sure we're all on the same page that this works for everybody. Everybody good with that? Oh yeah? Okay. And I want to make sure that this is clear for everybody that this is a poly. The poly has an array of vertices. The vertices have points, and the points have positions. And the positions can be expressed as a tuple of floats that are the point position in SOP space. And when I say in SOP space, I mean model space. And by model space, I mean the local space to this SOP. This is not your world space. We're just transforming things in the SOP, right? Cool? Great. All right. So we're going to need a little assistance from outside here. So we're up to the top. We're going to type import math. And while we're at it, since we're at our very top, my top is actually quite far away. Here we go. We're also going to say, we're going to make a couple defines for ourselves. So just kind of constant style. I'm going to say pi gets math.pi. Nope, pi. I don't know why I capitalized that. You might have to hit space in order to get it to not capitalize that. And also while I'm at it, I'm going to say 2pi gets pi times 2. I like having those around. Right? Now, might not have had to do that right away. What are we doing? Circle straight across. All right, so let's do something here. Just as an example, we're going to do a for loop, right? And if everybody's familiar with a for loop, we're going to just pick out a random variable name. I'm going to say I is going to be our counter here. In range, num lines, let it autocomplete. You can hit tab when you see it pop up like that. Num lines plus 1, and you want a colon. And you're going to highlight these 3 lines and hit control and then the right square bracket to indent and save. The right square bracket, this one.
You can also just go to the beginning of each line and hit tab if you're not in C line, if you're in something else.
Did you comment them up?
No, that indented them by 1 tab, yeah, or 4 spaces depending on what school of Python you subscribe to.
Don't mix and match, pick one.
Don't you mix and match. Okay, so now if I middle click, look at that. Oh, I don't know why I said plus 1. Let's get rid of that plus 1. Okay, not what I was thinking. So now if I middle click, look at that. I got 10 of them. They're all sitting on top of each other, but that's a fun start, right? So now let's imagine that let's put our first point back to 0, 0, 0. I swear we're getting to the circle. And our second one we're going to say 1i 0. And we're going to save. So everybody got this? Our first point gets assigned the position 0, 0, 0. We don't actually have to do that on every for loop, but we're building up something that works. And then 1i 0. So now if we go over here, we got kind of a fan. All right? Everybody got that? Sweet. Hey, guys. I'm building up steam here. Okay. So we're going to need... I'm trying to think if there's a way that I can get through these 2 hideous lines. No, we're just going to all have to type them out. Okay. So the first thing we need is we need this value, which is pi divided by the num lines. And actually, I want to move this. Before you guys do this, just take it, get it out of here, and just stick it right there. Right? So this is pi divided by the number of lines. And what that's going to do is that's going to slice our circle up into wedges, each of which, you know, when you add them up, it's the number of lines that we wanted, right? And notice that we did that on pi because we're only going around half of the circle. We're going to be drawing lines straight across the circle. So what we wanted to do is divide half the circle into the number of lines, and we're going to start there and go across to the other side. So this is our starting point. This is our ending point. Let's get into this tuple. And for our x value in this tuple, we're going to say math.sign of the quantity I times our gap. Let's just go ahead and save that. I have no idea what that's going to look like right now. I mean, I have a vague idea. It's going to be a mess. Yeah, it's a mess. Don't bother looking. Okay. And then naturally, if you guys are familiar with trig, I'm going to say math.cosine of I times the gap. And actually, from an efficiency standpoint, how many times do we do I times gap? Let's do it. I gap equals I times gap. And let's just get rid of all these multiplication operations in case we want to make a really complicated circle later. So everybody follow that. And we're going to leave the x value as 0. I'm sorry, the z.
I didn't know you could do that with the syntax in Python. You can just put two variables next to each other and multiply.
I have an asterisk.
Oh, sorry, you defined it.
My bad. Yeah, I added a line, guys.
No,
I made it a quantity called I gap. That would be super cool. That would be an amazing Lexer trick.
Can you scroll down the window a little bit just so that the text is on?
Oh, yeah, I'm sorry. Is that better? Let me get rid of some of this dead space here.
Can you show the result?
Yeah, let's see what the result looks like. It's a hot mess. That's partially because, let me just change this. You don't have to do this. I'm just going to change this back to 1, 1 so that it holds still. And hey, look at that. All of our lines coming back to the point 1, 1, except this first one, which inexplicably, oh no, they're not making it all the way. Wait, oh no, of course. So this is the outside of our circle, and this is the end of all of our lines. That's fun. I mean, you can get off on a tangent pretty quickly on this stuff, but if I called, hi, how you doing? If I called this thing with like 100, this could be attractive, and I might just want to print it. I mean, look at that. It's beautiful. You got like moire in there. It's not what we're doing. You don't have to do that. And I would recommend you be really careful when doing that kind of thing, because if you're doing something pretty complex, that's when you bork your computer. By the way, save in TouchDesigner. How's that? Whoops. Everybody just throw save at it. Okay. So we've got half of it, and now you could pretty much figure out what we're going to do next, I think.
Can we animate these buttons, like change them and...
You absolutely can. Yeah. Yeah, the question was, can you animate it? And yeah, I mean, you could pass in parameters that change over time. As it happens, we're doing this for the purpose of the robot, and the robot's not so good at animation. But someday, I want to get control over the actual serial commands that drive the robot in real time, and then you can, like, you know, use brainwaves and draw and stuff like that. Maybe we'll do that next year. Okay. Math.sign of I gap plus pi, right? Because we're just going straight across the circle. And the same thing, if you want to copy and paste, that's probably the best way to avoid copy paste errors. I gap plus pi. And then, oops, you're just going to have a 0 at the end. Whoop, not cop, math cop. I'd watch that show. Let me get rid of these spaces so it fits. Oops. Does that make sense to everybody? And I would imagine. Oh, yeah, straight across the circle. Right, I forgot that we were doing this one. Fantastic.
The Python again?
Of course.
Can you shrink the right pane?
The right pane. This one?
Just shrink it so that expression.
This one fits.
Or no, to the left side.
Oh, this pane. Oh. We're assigning 0 in the Z because paper is relatively flat. At some point, we've had discussions on the Plotter TouchDesigner Slack. If you guys are interested in joining that, you'd be more than welcome, about doing drawings that take over the raise and lower as like a minor Z-axis to be able to, I don't know, plot on undulating surfaces.
Hashtag art.
Hashtag art. It's hashtag plotter, actually, plotters. So don't confuse the issue, Elvers. Cool. Everybody did it? Everybody got Snowflake? Look at this, guys. And then, you know, naturally, if I change this value to 100, it looks way cooler. Look at that. Moire out the wazoo. Now.
Yeah, leave the code up for just a couple minutes.
Okay, okay. Can I help you, sir? You okay? You need help? You sure? Yeah, oh, yeah, sure. How do I get over there? Okay, let's see in your Sublime. Yeah. Here's some lost syntax on it. Yeah. The issue appears to be. Wait, go back to TouchDesigner. Middle click on that. I'm sorry, I missed it. Yeah, middle click. No pot. Okay, so line 3. Go back to here. If you could. Come on. You can declare pi there. Oh, yes. Lowercase. It'll autocomplete. Just change that to lowercase p, lowercase I. No, that's fine. Yeah. Just change this big pi right here to a little pi. And the I as well. Go back to just the I. Change the I. On that line, yeah, just change the I. Yeah. Now hit space. Okay, great. Yes. Yes. Okay, good. Hey guys, we did a drawing. One sec. Okay. Well, that's super cool. How'd you do that?
The same errors.
Oh, do you know what it is?
Yeah, but it's something I want to figure out.
Go to your CopyStop.
No, it's only that I gave it. So you gave the circle. You gave the end angle, the total copy or copy, and the two names didn't match. The variable name what I used here.
Yes,
and
that's
the copy.
essentially what she had.
So that's why.
Yeah,
Something I don't know.
it's cool. That's what she got. It's very cool. How we doing, guys? Do you guys need something up above?
Oh, yes,
Coming to you. Sir? Oh, really? Oh, it has no attribute sign. S-O-N, you said sun instead of sign. What you need here, math.sun. Huh? Hey, Mark. Yes, sir. Make sure you return on line 11, right before it messes up. Say return. Oh, no lines. There we go. Interesting. Well, it's not quite like that. Oh, I see. Transform it. Yeah, yeah, okay. Sweet. All right. So, now that we made this drawing, let's get some control over it back in the TouchDesigner interface. So, every every script op has the capability to make its own custom parameters. So what we're going to do is actually we're just going to grab one of these ones that we have already. And I'm trying to remember the syntax for this. Let me look at mine here. Yeah, so what we're going to do is on cook, right here, we're going to say the value A gets our script op par A. And that was already created for us up here. Oh no, wait, it's called value A. Let's just, we'll work with what we got here. Value UA, right? So I'll change B just so you guys see what's going on. You don't have to change this too, but I'll just call this label B. Label B, and I'm going to call this B. And then if again, you don't have to do this, but I'm just showing you how this works. I'll go back over here, and I go to my script tab in the parse, and I hit set up parameters. I go back over here. I change this to label B, and this variable now comes in. You can see it's called B in Python world. Over here, it's value A. This comes into my script op in the code that I can execute here as par member value A, right? So I assign that to an easier thing to refer to. I called it this little A here. And now this is a good habit to get into. Let's go back into TouchDesigner and let's change this to a reasonable value before we monkey with it. So change that to 10. You can change it to 100 if you like, just not 10,000, depending on what kind of computer you have with you. And then we're going to go back in here and we're going to replace this 100 that we hard coded in with A, right? And save. And now if I go back over here, I think you can figure out what we're about to do. Good times, right? So let me go back over to the code just so you guys have it. The two things that we added were A gets this quantity value A, which we're pulling in by using the page class to append a float member that has this label that's what shows up in the TouchDesigner interface, but actually comes in as this variable name, value A. And it's a float. I could have made it an int for this context, but floats will be, we're just going to keep reusing A and B and maybe C later on. So in comes A here, and it gets added to this page that doesn't get used again, but this is a reference to either the par or the page, actually. I think it's the page. But down here, we could pull that variable back out by referencing the par called value A, and we're going to pull the value out on every cook, we're going to check that value again because the user might have changed the interface, and that's how this value gets changed. And then we're passing it in as an argument to our num lines. Now, when I look at this method, I don't know. I mean, I know what SO is because I'm going to have that on all of them, but I don't know what that value is. So for sake of legibility, I'm going to call this the name of this named keyworded argument over here. Num lines gets A. It still works the same way. It's just good practice to do this because when you start making these drawings that have like 4, 5, 6, 7 arguments going in that are all the different parameters to control how many points things get and how quickly they move through space and whatever it is, naming them makes it much more legible from the drawing side of things. And again, I use this as like a terminal or something. It's like a history, of all the drawings that I've done. So I'm already bored of this one, so I'm going to comment it out. But that goes into my history, and now I know, because I passed this a variable, that doesn't really help, but I might make myself a little note that was like 100 was tight. Whatever. I don't normally do that, but you get the idea. Okay. Or maybe I'll use the A. This is probably a better practice. Let's do this. I'd use the A, and I'd monkey around with the interface and stuff. I'm going to uncomment this out one more time. Oops. Not control period. Control slash. I'm going to save it. I go back over here, and I'm like, oh, that's cool. 80. Well, not point. Okay. 81. Yeah, 89 is the value. That's really sweet. So I might go back over here, and for safety's sake, just get rid of the A and hard code in 89. And that's my drawing, Did my first drawing. Everybody on the same page with that? We're just going to basically take that same principle and make ourselves some more tools. Now, what is it about line that is annoying right now? Well, I would argue that it's this, right? I would argue that we need to, for every line we create, we need to capture the poly that comes out. We need to refer to each vertex in the line. We need to pull the point out, and I'm just going through this again because it's important to understand this kind of nested structure, to get to the position member of that point and then modify that. That's kind of a pain in the butt. So let's make a new tool called line. This is just my dumb naming, from to. And we're going to pass it the script dot. We're going to pass it from. We're going to pass it to. And we're going to pass it num points. And we'll default that to 2 as well. And this is a good habit to get into. I'm going to put my colon, and I'm just going to say pass. And I'm just going to make sure that I didn't do anything super dumb right away. Line. It's good to know that things work one thing at a time. And I'm just going to pass. And you know what? I didn't do this on my original, but let's do ourselves a favor. Let's give these default arguments. We're going to say 0, 0, 0. And 2 is going to be 1, 1, 0 by default. I'll save that. And this way I could just call line from to with script dot. And if I go over here, make sure I don't have any errors. And I'm not getting any unexpected geometry. So has everybody got this declaration lined up for themselves? Okay. No worries. Ah, nuts. We need to write one more helper method before we do this. This wasn't there in my rehearsals. Okay. Let me know, anybody need help? Everybody on the same page? That header? Okay, all right.
Tried using from as the argument name, and I think that's preserved.
I think that's probably how I ended up with what I have. Yeah. From, because that's import. From math import sign or whatever.
Oh, right. But I could also, I could capitalize it or something too.
Everybody good? All right, before we do this, we're going to make another little tool. This actually doesn't draw anything, but it's going to help us I feel like there's got to be a built-in. I hope somebody's going to shout this out and be like, this already exists. Linear interpolation is frequently referred to as lerping, L-E-R-P. So we're going to make a little lerper here. And we're going to say lerp tuple because this isn't built into Python, right? Or TouchDesigner or anything? Sweet. Okay.
So you can do it with TDU points and vectors.
Yeah. Wait, how do you lerp them?
We multiply the vector between the two of them
By a fraction,
by a fraction.
by a scalar.
And offset them. That's good.
All right, well, let's do this hard-coded implementation first, and if we have time, let's go back and read. I learned a lot about TDU while doing this, after doing all of these. And I should go back and refactor all this stuff with the TDU stuff. But what we're going to do here, a linear interpolation, I thought this was a chalkboard for a second, so I was going to draw something. But a linear interpolation is basically you're going to say, if I have the number 0 and I have the number 10, and I want to interpolate between them, I'm just going to crossfade, essentially, between 0 and 10 based on some scalar value, some floating point value, normally from the range of 0 to 1 is how this usually works. So 0.5 of the way between 0 and 10 would be 5. That's an easy example, obviously. But if we have 2 points in space to interpolate between these 2 points in space, we could use the TDU module, which is the smart way to do it, and take these 2 points and store them in vectors, right? And then multiply those vectors by a scalar, right?
Wait, you store them in points.
Store them in points, and you can interpolate points by multiply them by...
Positions, right, and then you create a vector between the two positions.
I wish I could bring up the documentation. Am I on the... I'm not. I have no network access. Well, oh wait, I am using TDU vector. Here we go. So our start value, TDU vector. I was way ahead of you, I just forgot. But I should use a TDU position. It would be the same thing.
Well, no, they're different. I'm pretty strict about it. It's a position holds the position while the vector goes just in the direction.
Let's do this. TDU position. And we're just going to decompose our start tuple because our start is made out of 3 values. It's an X, Y, and Z. So you're just going to type the same thing 3 times.
You may just take it.
You think so? Let's try it. Don't follow me just yet, guys. Let me just do this so that you don't type a whole bunch of TDU position of stop, and then return the value of, and this is basically the rearrange thing over and over again of stop minus start. Am I doing this wrong? Plus the start. Would you have done this another way? Okay. Great. Let's see how that works. I'm going to say draw lerp. I don't have any way to inspect this. I'll type it. Tuple of 0.5 and then 0, 10, 0, and 0, 0, 0. And I'm going to save that, and then I'm going to debug this quantity. Again, don't necessarily type this just yet. Q equals this, debug Q. And then let's see what happened. Hey, you guys were doing it the right way. I'm so excited about this.
What does TDU stand for? Like,
What is the acronym for?
TD utilities. So it's any, basically we put anything there that kind of just standalone functionality that's not tied to an auth or particular part of TouchDesigner, like the project class or the X class. It's just random
global
utilities.
variable?
Not local variables, no. It's just general functions that kind of we do that might be useful for people.
So if you guys have ever used the math chop and you have the rearrange capability in there, that's pretty similar to this function that we're doing right here. Not exactly the same, but it's the same principle, which is to say we're finding the range of values that we're dealing with. We're multiplying it by some fraction, which is what this F stands for. I didn't create my passed in the F, right. This is some fraction from 0 to 1. And I could like put in a, if F is greater than 1 or F is less than 0, raise value error. But we're not, Python, you don't really do this kind of stuff because you assume that your users are consenting adults. So we're really just this is going to be it for our lerp, right? So we're passing in tuples, and by tuples, it's this same idea here, 3 values, which represent a position in space. We're casting them to a TDU position, and we're taking advantage of the fact that TDU positions can do this kind of math, which will be respective to the position in the tuple. So when we do this stop minus start, it's going to subtract the positions in the way you would expect positions to subtract. And again, I wish I could bring up the documentation because it's really explicit on how this stuff works, but I'm not allowed to use the internet. And then we're going to add the beginning of the range again. So if this math doesn't make a ton of sense to you, that's okay. I promise it works. And I can get rid of this because this was just an example. Is everybody cool? Does that make sense? All right. So we're going to use that to create a line from one point to another point. All right. So we've already confirmed that this header is fine, that we can call this with just a script op. We'll add some arguments in a second. But for now, let's just make sure it works with our default values. So we're just going to make a line with our num points argument. And now that we've called this and I've added this in, I'm just catching the return value of this poly, right? Go back over here. I got this line with the default values as expected. So that's good, right? And now what we want to do, and there's a way to rework this with NumPy, which maybe we'll do towards the end to make this a little faster, but in the range of num points, so we're going to go through this, we're going to enumerate all of our points out of this, right? We're going to say that line, and that's an L. I'm using a lowercase l here, which is probably foolish, but I like to live dangerously. That's a lowercase l dot point. And then we're, again, pulling out the position member right here. Same thing we did before. We're going to reference every vertex's position. And just to make this explicit and a little more legible, what I'm going to say is f gets I divided by the num points. Right? Minus 1, actually. Because we're 0 addressing this. Minus 1. Okay? I don't think I have to cast this to a float. I think we'll be okay. Right? And what we're doing is, now we have this fractional value as we go through all the points that we've created in this new line. And we're going to say, for each of those points, we're going to lerp our tuple with f from 2. Matches our sig down there, right? Did I call this from 2 before? Oh, line from 2. Right. I can get rid of this pass just to make it a little clearer. I should have 2 spaces between functions, but we don't have room. Does that make sense? So what we just made is now we made an abstraction for the line method, or the append poly that makes a line. And then we've made an abstraction for line that lets you make a line from a point to a point. So
Also, the f variable, what is that?
the L, yeah, I'm sorry. So the f represents how far we are.
So it's like f for far?
Fraction.
Fraction, okay.
Yeah. I don't know. When you pick one letter, Python's like the one letter thing. I normally write like really long variable names. But so the f, what we're doing here is we're figuring out how far into our line we are, because we're only working with 2 points right now, so this seems really dumb. But if we make a line that has, for example, 100 points, and we when you make a line by default, you're going from 0 to 1. All those points are going to be between 0 and 1. What we actually want to do is make them from whatever to whatever. And what we need to do is go down the line and adjust all the points in sequence from to our 2. But we need to do that calculation. We need to lerp that calculation along the line. It's literally a linear interpolation from place to place. So now we can test this out. And we can say from, I don't know, let's always go from 0, 0, 0 because it just makes things easier to read, to negative 100. You can put in whatever numbers you want. 99. Doesn't matter. And let's just leave it at 2 points for now. Hopefully that works. Make sure you save both of these. And let's go back into TouchDesigner and save if we see what we want. We sure do. So if I inspect this, you can see here, I'm going from, I don't have my origin point, but the whole bounding volume is 100 by 100 by 99. And my extremes are negative 100, 199, and my other points are 0, 0, 0. So you can see that here, or of course I could inspect it in my SOP2 DAT. And look at that, there are my 2 points. Now what's super cool is I could go in here and I could change this number to, I don't know, 10. I should name those arguments, but I'm running out of room on the screen, but it'll still work. And here we go, now I have 10 points that linearly interpolate from place to place. And again, the line's going to look the same, but it actually has 10 points. I want to show you a little Python peccadillo here. If I were, for example, to give this argument a name, this keyword argument, its keyword, it's going to complain. Because I have a positional argument following a keyword argument. Now what that means, it's fine to use keyword arguments, but only after all the positional arguments. And by positional arguments, that's basically the way you're used to doing it without keywords. These are now all positional arguments. And it knows what they are. It infers them from the context. So it's saying, all right, well, this 0, 0, 0 must be passed to FR. This negative 100, 199 must be passed to 2. And then this 10 must be going to num points. Now I can say, I can start at the end, and I can say num points, whoops, you're killing me here. Num points gets 10, and that's fine. It's not going to have a problem with that. You don't have to do this. I'm just little keyword argument thing. But if I did that, it's totally fine to, like, let's say delete, let's say my first argument here, because I have a default for it, and it'll still work because the default will kick in. But what I can't do is I can't, like, let's say from, actually I can do this as well. I can say from, now my from is going to be this value. My to is going to pick up its default value, and this is why you use keyword arguments, is because now you don't have to use all of them, right?
And you can put them in different orders.
You can reorder them. Yeah. I mean, if I didn't want to say my number of points, I could just delete that because I had a default, and I have keywords for all these. So this is part of why this is good practice. It makes it clearer, easier to read, and it makes your functions more versatile, especially if you can decide on, like, really reasonable default values. How's everybody feel? We all got linear interpolation line from to? Sweet. Hey, I'm excited. All right. We did that. Line to line. This is a fun one. All right, we're going to put together some of the stuff that we have. Let me find my line to line code. Line to line. Okay. Yes. Oh, are you referencing it in your, do you have a capital P? Everywhere you have it, do you have a capital P? Oh, you got to do minus I and range from 1 point to minus 1. You guys are using Sublime or another IDE that has autocomplete, you should use it. When you start typing a variable name, you'll see a list of possibilities. And as soon as you've narrowed it down to the one that you want that's underneath your selection, you'll see it kind of pop up underneath your cursor. Hit tab, let it type the rest of it. That seems like a simple thing, but it will save you all kinds of dumb problems later on. Yeah, I think so. Yeah. I'm not a VS guy. We're going to do one more tool, and then we'll take a quick bathroom break. How's that? Okay. Everybody good? All right. This is a fun one. We're going to do line to line. Anybody guess what the first argument's going to be? Oh, this is. I don't know why I called that. Oh yeah, it's not a drawing, it's a tool. Okay, line to line. First argument, script op. Right, we're going to pass it our script op, and then we're going to pass it two things that we're going to call lines. You'll see how we expect that to be passed in a second, and then of course a number of points. So what we want to do here is we want to connect two lines. What's built into Windows? Is it like Mac Paint or something? MS Paint? Paint? Yeah. Whoops. We want to do that thing that you all did when you were doodling in class, where we have a line with a number of points on it. Point. I'll do 4 points so that I don't make myself crazy. Point. Point. Right? And then we have another line. Point. 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 And then we want to connect them either straight across or the fun way, like this. Oh, wow, that's real good. Oh, wow. Stan makes this look so easy. Okay. Yeah. When Stan does it, it looks totally good. He's explained some like really complex geometry stuff with that. That's my first try winging it on that. Okay, cool. So that's what we're doing. We're going to do a line to line. And we're going to use the stuff that we already made. Here we're going to use the two tools that we just made, which are abstractions of other tools that we just made. So here we go. L1 start and L1 end are unpacking this tuple. And this is a way to unpack tuples here. That's lowercase l. L2 start, L2 end gets L2. So we're assuming that L1 and L2 have two things inside of them, and we're going to pull them out into variables that we can use. Let me put this up higher for you here. Okay. So what we're going to do, again, we're going to loop in range of num points. All right, we're going to do this operation once for every point. And the same thing, we're going to say f gets I over num points. Should that be -1? I don't know. We're going to find out. That kind of counting is called the fence post problem. There's a great description of it on a website called Better Explained that I would really recommend you check out. The example being, if you have a fence, you might count the posts. Say how many spans is the fence. It's like how many posts is it or how many spans. But it's like if I said to you, vacuum floors 8 to 11 of this office building, you'd know, okay, I got to do 4 floors. And I said, do it between 8 and 11. How many floors per hour are you doing? 3/4 of a floor per hour. If I said I'm going to be in Berlin from the 8th to the 11th, how many days am I there? It's totally ambiguous. So we have a problem in English where we're not very specific about whether we're counting the fence posts or the spans. And it comes up in programming constantly. And I've not resolved it for myself. So I don't know. This might be num points -1. We're going to find out in a minute. Okay. So our first point is going to be lerping tuple with our fraction, our L1 start, and our L1 end. Oops, end. Right. And our second point is going to be lerping tuple. Oops. From our L2 start, and again, use autocomplete if you can. L2 end, right? And then guess what we're doing? Line from 2. Our script dot, point 1, point 2. No, that's a lot of typing, but it's worth it. Everybody got that?
Get a little more.
Okay. Pretty good? Any errors? You looking good? You might get an error. You wouldn't know it because we're not calling it yet. Yeah. Good? Okay. So we're going to do a drawing with that. It's exactly that drawing that you used to do in math class with your ruler. We're going to call it a saddle because it kind of looks like a saddle. We're going to, our arguments to it are, whoops, script op, and a num lines. Oops. Okay. This is going to be really easy. We're just going to make two lines from a point to a point. I should probably make a line abstraction of some kind. 10, 10, 0. You can put in whatever values for this you want. Totally up to you. Just make sure you get the parens right. So you're putting 3 tuples into a 2 tuple. And that's what this line thing is that we were expecting it to pass in right here. That's why we're unpacking this as the first point. You know, the start, the end, the start, the end. That's what we're taking out of these, right? And then line to line. I'll scroll down here. Line to line. Script op. Line 1, line 2. We'll pass it our num lines. So you guys all know where we're going with this, right? Since we made a new drawing, we're going to go over to our script op. Saddle. We called it saddle. We'll pass it the script op. And I don't know, 100 lines. I feel safe. I think it'll be okay. And I'll let you all get to the reveal yourselves. Hopefully that worked.
Can you maybe put the previous function you just wrote also?
Oh yeah, totally. Let me see if I can. I'll collapse the circle straight across here. Okay. All right, and then yes. So these are the 3 things we're using here. I mean, we're also using line from to, but
So, quick question. Does it matter what order we put these function definitions in?
I don't think so. No, I never understood this, but Python doesn't care about things being higher or lower on the page. I don't. Is that right? Yeah. Part of the reason probably Python's a little bit slower is it searches the whole namespace and doesn't insist that things get compiled in this order. I don't know. Oh, it gets compiled. Yeah. I know that's a lot of typing. Everybody got that? Let me put that higher up. Just want to show you what that looks like. Hey, oh, look at that. Isn't that fun?
Which shortcut do you like zoom into the geometry?
It's the no. Hit A, and then middle click and drag up and down. I believe. No. Like click and hold, middle click and hold.
I know what you mean, but there's a button which you can focus, like get into.
Yeah, it's middle click. Here, I'll show you. I think it is. It's a muscle memory thing. Yeah. You drag with the middle click up and down.
Isn't there a shortcut that it just frames the?
Oh, H. Yes, for home. Yeah. It should be set to auto home though. Yes.
Did you
call it from your script doc?
Like this.
Oh, cool.
If not, it's like straight up code. If you want like
You might have gotten disconnected here. Save this. Grab, select all. Control A. And then save. Oh, I'm sorry, copy. Yep. And then go to TouchDesigner. And edit. Yeah, edit that. It's still there. So, did you save this? So maybe this guy's just going to go back in there and type. Control C.
Oh, I see. So
Yeah, I mean, yeah, it got disconnected. I don't know why that happened. That is the option. This is what Elber said a minute ago, guys. I just want to. I don't know what the sequence of events that causes this to happen is, but maybe if you close or reopen TouchDesigner, that's definitely a pretty obvious one. But you may be making changes in your Python and nothing's happening in TouchDesigner. That often can be fixed by just reopening the text thing that you think you're editing. If it opens in the exact same spot, you're fine, and you have another problem, which I don't know what it is. But if it opens, let's say, like another tab, and the one that you were working on is now in the background, that's stale, and it's no longer connected to TouchDesigner. So you're going to want to grab it all, copy it, and then go into the one that just opened and paste it over it. That's the only way you're going to save your work. Does that make sense? So that'll happen pretty easily if, for example, you do a function like this, and I put in 1 billion over here. TouchDesigner will crash, but Sublime will not. So your work is not gone. Like almost everything we're doing is in Python here. So you can reopen your TouchDesigner project, change that value to something that is not 1 billion, copy it, and paste it over where you were working. Make sure you close your old one. Does that make sense? Just, it's really easy to crash TouchDesigner when you're doing this kind of stuff, because now we're starting to draw, we're doing 10 lines here, each of which have 2 points. But if I were to, for example, call line to line, and I gave line to line an argument that was like 100 points per line, now we're talking about some geometry, or 1,000 or something like that. It starts to add up. So you can really easily crash TouchDesigner. You're going to want to open Sublime. You're going to want to grab all your text in Sublime and make sure that it's still there. Save those files. You can externally, if you like, and make sure that you copy them back into TouchDesigner when it comes back. So you guys, let's take a bathroom break for 10 minutes or something, right? Come back at 11:50. Cool. And I'll maybe tell the robot to do something. Yes?
Mine is the code look like this, okay, but doesn't make underline.
I'll come to you. I'm going to try it.
Ah.
That's cool. Maybe show me your own.
Do you have the line? Does the code is
0, -10, 10, 10. But have you rotated in space? Did you like home it? Rotate it? Let's see if it's like drawing out another axis. Wow, that's cool. Okay, let's look at line to line. So you got fractional value. Unfortunately, this one's hard to test without actually. You know what you could do, just to try to make more sense of it, is change your 2 lines to be like line 1, like 0 to 1, just 0, 0, 0 to 0, 1, 0. And then line 2 be like 1, 0, 0. to 110. Yeah, that. Let's just see. Odd.
I just try to save the space.
Can I have this one for you? Would you like to change this number?
Show me your line function.
Let's go for a restart, TouchDesigner, if it's like now calling.
You could be, absolutely. No points instead of 2. That's why that's not.
Thanks.
It's hard to see on the projector, but that's an asterisk. TU plus.
Five.
Okay. No, that's right, because that's what you just did. You just changed the.
The plus.
No, you're good. This is right though.
Yes.
Yeah. Okay. So is that what you had?
No, for some reason, so I
Thank
had
you.
it, but it's like the start and the end of the same. That's why it's different.
Oh, yeah.
Now, the only thing I'm doing differently is I just let it back.
Sure. You're doing count. Yeah.
Yeah, that's the only thing.
Yeah, I'm super consistent. Show me what you are.
Just
Oh, huh. How do you do that?
you have to on display here, it's off by default, but in the background, over the geometry, but that's new, I'm pretty sure.
That's
It's
exciting.
99.
Is it in the experimental or is it in
It's in the stable.
okay. Sorry. So let's go back to
My friend, can I have another little question? Well, actually, it's
Just one?
no. Let's just sit down, take a sip of water.
It sounds tough. I'm coming though.
No, it is very. I'm pretty sure it's easy. It's just I don't know if you had a break or anything. If you had time to breathe and stuff.
Okay, let's take a look.
Yes. I love the background. I'm gonna do it.
Basically, what it says to me is that
Oh, you know what I want?
it's once
Like my problem was that it's not cell zero. I changed everything from zero. He was doing 1 and 2, and I did 0 and 1. So I had just they were both 1. So
just integer, like
it works. But that's what was happening with me was the start point was the same as that point. So I made it the same.
Go for the same way.
Exactly. Yeah.
Maybe 10, 6, 0.
There you go.
Then 10, 0.
and then that's what it and you know what? Well, now I know it because I started with just drain and then it's
Yeah.
instead of just typing.
Now we try to fix the number.
Yeah.
Cool. Thank you. That was it? That was the only one?
It's easy one.
Got it too. Easy. This is like a real hazard right here.
Yeah, no.
Let's see what we can do. We can.
You like danger, no?
We really need some gaff tape.
Yeah, I don't know where to get it. Sorry. I guess the people who run places might yeah. It's something. Oh, you know what you could do also is put it on there. Maybe under that one as well.
Burrs.
I'm impressed this thing managed to continue to work.
Is it recording the internal hard drive?
Now it's even more dangerous.
With the resolution changes in the
Oh yes, it totally it hung in there. What's the capture card?
It's an Elgato game
Uh-huh.
capture card.
Oh yeah, yeah, I've heard good things. And that's also an H.264 encoder, right?
Yeah.
In the box, yeah. I've been using the Magewells to
yeah?
get information on. They're so good. Oh yeah, it's like plug and play, man. Really rock solid, cheap, small.
I got turned off of the whole USB capture cards
It's USB 3.
because the first one I tried was the Blackmagic one.
Oh yeah,
And it like required the most obscure chipset.
Blackmagic makes my palms sweat.
It's a dangerous game, but a cheap game.
They're so cheap.
That's the thing.
Yeah.
They're so cheap.
They're in a class of their own price-wise,
Yeah.
but you get what you pay for, which is like Russian roulette every time you restart. It's kind of like those Matrox, the triple heads. It's like,
See, at least with the Blackmagic, I can make it work always somehow.
yeah? What, like environment variables and stuff? How
No,
are you?
I mean just like if you reboot it enough, it'll work. But the
Oh.
Matrox, like every time you touch
never
a
know.
setting, it like makes you reboot, and then it might not.
And then it reassigns the monitors.
I just
Yeah. Yeah.
Data paths.
Yeah.
and data paths are
But
so-
the client's eyes bug out of their heads when you tell them how much that thing is. Like, what does it do? Why is it so
I mean,
expensive?
if they can't pay for that, there's no way in hell they can pay for us. So like,
Mhm.
whatever. That's the least.
I've been selling a lot of data paths. Well, the FX4 makes it even harder.
We should get one of those referral codes from DataPath.
You should just get a reseller
Yeah.
account.
I think they do
Get a
that.
little bit of kickback.
Yeah? To small fries?
Hmm?
To small fries like this guy?
They might actually.
Every blog post of mine from now on is going to be about DataPath.
Yeah. Just a quick shout
How
out.
to use DataPath
Yeah.
in TouchDesigner.
I just want to remind everybody that the data path is my preferred choice. Video wall controller.
It'll default to that at some point. Oh, Jesus.
Yeah. Just want to get a better look at you. Oh, we're going to NumPy land. Oh my gosh, you guys. Yeah, I'm trying to make this as touch specific as possible, but once you get into Python and SOP, it's tough. The position thing is very good. I should be using more of the TDU.
Yeah, like if you standardize across, like always, instead of passing tuples around, just always pass
Positions.
around, yeah. Then
Go back
then the variable's already there to, if you want to manipulate them somehow,
I
right?
should go back and redo that again.
What might help, because what I'm noticing is a lot of the issues are just really simple Python, like missing colons, typos.
Yes,
Um,
I should speak those out loud.
Well, what I would say is maybe do a couple lines, like talk and type separately, so that they're not trying to both listen and type.
I see.
Yeah, like talk
Yes.
about something and then just put the code up here and copy this.
Yes. And or like say the code out loud, including the punctuation.
Yeah.
I used to have an English teacher that did that.
Because that's like most of the issues that I would say is like, oh, the piece got to be captured, or the colon.
Yeah.
Or this one is like, that's a thing.
Yeah. Okay, I'll do a better job of that.
So
It's
are we
11:51.
Are we
Where's your
skipping
peoples?
the install of?
Yes, I think, well, given the internet situation, the fact that I can't even get on,
Did you go down? Did you try reconnecting?
I did, yeah, twice while we were talking, because I want to bring up documentation. That was the whole idea.
There might just be so many people.
Well, and there's an MQTT workshop happening on the same land.
Oh, right. Ah, yes. Should have brought a router for that one.
Nice.
Yeah, God knows what this router is or where. We're missing some people. Are they out there?
I'm gonna fetch 'em.
Get into NumPy territory. We only got what?
You got an hour, or a little more than an hour.
Alright, I gotta think strategically about what we're actually gonna do here. So I saved some good stuff for the end, like some tools. Alright, square. Oh yeah, definitely gotta do this. Getting chops in. Curves. Right, that one's not working. Sampling tops. Definitely gotta do this. Definitely gotta do that. Faking perspective.
You're not cutting it down very much.
I have to do that too. What was that?
You're not really cutting it down much.
No, but these are all important. I was just trying to get to the point where I could do these things. I definitely got a sample chops, so let me skip NumPy for now. I'm probably going to need it. I am going to need it. Oh, cripes. This was also
What do you use it for? Some of the mathematical functions?
just as you get more and more numbers. Yeah, it's just like being able to like multiply an array by a scalar and like have huge number sets and not worry about doing operations on them in a loop. You know, optimization basically. But you don't have to do any of these things with a lot of numbers. But like the things where you're sampling chops in real time, like using the camera, my machine, which is relatively current and fast, goes down like 2 FPS. With anything that like you can recognize yourself in, or whatever, like doing the selfie cam kind of thing. Oh, we're back. Hey, we're gonna do a little edit. We're gonna do the radio edit of this. Gosh, we need this though. Let me see how fast we can do this without making a ton of dependencies. So what I want to talk about is how we can sample chops. Is that right? Square and chops. How we can sample tops and chops in our Python context. And I'm skipping some things, so I hope we don't end up writing a whole bunch of functions in a row that we haven't done a drawing with. The idea was to do a tool and then do a drawing with it, and do a tool and do a drawing with it. But because I want to get to some of these things that are like really TouchDesigner specific, I'm gonna skip some stuff. So bear with me if I get us, if I draw us into a corner. That's not the word. Paint us into a corner. That would have been better. Okay. So we're gonna do a thing I call Perlin Grid. So here we go. We're in Saddle World here, Saddle Town, and we're gonna go back over to our code. Excuse me. Do I need? We got to do a square first. Okay. Not that I hate squares, but we got about an hour, and I really want to get us to some good stuff. All right. So def square, and square is going to introduce us to NumPy. Gosh, I hope everybody has NumPy installed. I think so, yes. I think it's built in. Actually, did we do a circle yet? We didn't. Because it occurred to me last night as I was falling asleep that a square is just a circle with 4 sides. But here we go in the way we're drawing things. So I'm going to declare a square method. It's going to have a default argument center here that's just 0. We're just going to default by drawing it right in the center of things. It's going to have a size of 1. That's going to be my what's a square? You understand what the size means, the length of one side. And then we're going to be optionally going to be able to rotate it. Okay? So, how do we do this? Well, I'm going to introduce you to doing this with a library called NumPy. NumPy is a C-based scientific computing library that basically lets you handle huge amounts of numbers in technically flat arrays. They're arrays that are all one-dimensional. And it can do math on them really quickly, and you can pretend that they're matrices or two-dimensional or three-dimensional or n-dimensional. We'll only be using 3 for the most part. Why are we doing it in NumPy? Because it's a lot faster. And ideally what we're going to do right now is we're going to be able to draw a square, and then we're going to be able to do sampling of some other input to make drawings based on a chop world outside of our SOP quickly. Okay, so we're going to make an array of points. This is a NumPy array. Oops, we didn't import NumPy. Let's go to the top. Import, and you got to do this in mathematical order. Import NumPy as NP. Pretty sure that's what it is. And that's pretty standard. That's what people normally do. When they import NumPy, they call it NP. So in Python world, you can use this add as reserved word to rename a library when you import it give it a different name in this context, in this namespace. So now we can say NumPy, and we're going to make an array of zeros. And they're, for all intents and purposes, they're numbers that are close to 0. And I just want to show you, I've made this array that is 5 rows of 3 columns. You don't have to do this, but I'm just going to show you what it looks like if I debug it. oops, debug. And I recommend using debug instead of print because debug will tell you what line number it printed from. I try not to have too many things printing at any given time, but what? What is it with you? Line 15. Oops. This must be my import. Uh-oh. Now I'm scared. Oh no, maybe this is that's an old error. We're good. So I'm gonna call my my function here. So I just commented out my saddle. Control slash. And I'm gonna say draw a square with my script dot. And the rest are just default values. That's fine. What that debug is gonna hopefully, yeah, here we go. So here's my, oops. Here is my new array. And my new array is 5 by 3 of these, we'll call them tuples, 3 values in a row. And what this lets us do is draw a square because a square has to be defined by 5 points if we're going to be connecting them in this context.
Can you show again the import thing?
Yeah. The import just numpy, N-U-M-P. It's like numbers in Python. NP, as NP. It's this line.
And so how did you get debug to print it out?
You just, debug is just instead of print, you can say debug.
I don't see the text.
Right here.
Yeah.
Did you call square?
Yes, I did.
Okay.
Oh, no. A circle and a square is not.
Yeah. We skipped the circle. So that was just so you could see what that empty array looks like of zeros. And normally what you would do is you would make an array and then you would add things to it as you go along. But in NumPy, that's not really copacetic. You can do it, but it's super slow. Gosh, we're going to type all this out. Here we go. Points of 0. We need this, so we're going to do it. So the first point is going to be, hang on, let's make this quantity because I think we type it a bunch of times. Half size is size over 2. Right? And then we're going to make this array of points, and they're going to be center of 0, or center index 0, minus my half size. Make sure you use autocomplete. And center 1, minus half size. Why are we doing this? Well, just to do the drawing. I don't even know how to erase. Can I get a bigger, how do you, is it like Photoshop? Nope. How do anybody know how to get a bigger brush? New drawing. Yeah, that's a good idea. Thank you, everybody.
Make sure to save this one.
Yeah. Okay, so we're doing point 0, 1. I think we're doing it in this order. 2, 3, and our center is here. So we want to go, this is, negative half the size and positive half the size in the y. And then from the center again, we're going half the size and half the size. Does that make sense? So that's how we're going to draw this square. So we're going to, for the first point, this is the bottom left. I did the order wrong, right? Bottom left. And now we're going top left. You don't have to do these comments, but our first point, or our second point really. And let's just copy this whole thing. It'll make it easier. Just be careful with your inserting. So we want to say center 0 and center 1 are always the same, but instead of subtracting half the size here, we're going to add half the size because we're in the top left, right? So we go left in the x and up in the y, so minus and plus. And this is minus, minus, this bottom left corner, and then minus, plus, right? And now we're going to do top right. Whoops, top right. Oh my goodness. Whoopsie daisy. Copy the whole line. It'll make it easier on you. Right? 2. So you want to change points to 2 here. Definitely got to do that. And because of the top right, we're doing plus on both of these. So this is going to be plus, plus. So
just a question with the points. Why is it a 0 point?
Yeah, I was
Yeah.
thinking,
Yeah.
it's like a method of like you would like to do it like this. It's like 0 dot.
What
In the end.
Oh, this is our third value. Our z-axis is always 0.
Why is there a point?
Why is there
It's a float.
the dot?
So they know it's a
Yeah.
float.
Oh, so it's a floating point value. Yeah. It'll be fine with just without the point.
It's shorthand for another, like if you put another 0 at the end, it's the same. So 0th point is just like a short form for 0.
Yeah.
Yes. So that decimal place tells, it's probably not necessary, but it tells the context that we're dealing with a floating point value and not an integer.
Certain like GLS open compilers will complain if you don't do that like on share.
Yeah, it's probably not necessary here. Just force of habit. But I promise it won't slow things down.
It's good form.
Yeah. Yeah. Making it explicit. Okay, point 3 here, it's actually our fourth point, is going to be our bottom right. So we're adding in the x, right? We're going to the right in the x, and we're going to the left in the y. I'm sorry, not the left. We're going down in the y, so this is going to be a minus here, right? And then we got to go to the bottom left again. Oopsie daisy. Ugh, yeah, this relies on another function. I was just really too ambitious about how quickly we were going to go through this. Okay. The fourth point, we're going back to the bottom left, so it's the same one as the one at the top. So we're going to subtract and subtract. Okay, so those are our points. And you don't have to do this again, but I'm just going to debug our array of points so you can see it. And again, debug is a good call because you get to know what line number it's coming from. And then NumPy does a nice pretty print for you. And look at that. So we got -5, negative half, negative half, negative half, positive half, positive half, positive half, positive half, negative half, negative half, negative half. We're going around the clock. Great.
I was about to ask why there's 5 points, but I realized I guess if you're drawing it,
Exactly.
it's not going to go back to the
Exactly.
point
You would get an
unless you
open.
explicitly
We could call this a closed poly, but the behavior going down the chain when you go through SOP to SVG and through Inkscape and stuff like that is a little wonky with open and closed polys. You can't assume that it's going to close off the polygon for you. So we're doing another point back at the point where we started. Okay. Do we need to do rotation?
Quick reference to debug is very similar to print, but it just gives you a bit more information. So you can interchange debug and print.
Yes. But debug, if you have debugs all over the place, if you have prints all over the place, you don't know who's saying what. Unless you're making these print statements that are really explicit and formatted where it's like, hi, I'm this function and I'm doing this value and I'm on this line at the moment, but it might change. And, like, with debug, you could just say debug and it'll report where the context is. So if I go back to TouchDesigner here, you can see that the debug is on line 37 of my NN draw method. It's very helpful. Great. Okay, so I think we do need this rotation. Nuts. You guys. Okay, we're going to do it. So now we're going to make this thing rotate. So the points is going to subtract. We now need to, the first thing we're going to do before we rotate actually is center this thing on the origin. Because the best way to rotate a point, I'm only passing in a XY center. That's probably dumb. I could have abstracted this a little further. But before you rotate, you really want to move your geometry to be centered on the origin so that you can rotate all the points around the origin with the same thing. And then you're going to add the center back in afterwards. So let's just take this. We're going to copy that exact same line. And we're going to put the center back. So I'll put in some comments here just so you can see them. Center on origin. Recenter. Recenter. Okay, so this did nothing. These are the reverse of one another. Right? And now we're just going to, there's definitely a more NumPy way to do this, but we're going to do this with a loop. Do you guys know about enumerating in Python? This might be helpful. Enumerate. So normally what we would do in a loop is we would say for, we might, don't copy this line, but we might say for p in points, right? And that's going to enumerate points. It's going to iterate through points, I'm sorry. And it's going to extract all the points, and in each for loop, I'm going to have p, and that's going to be one of my points. Or if I'm going to make it look like the one below it for point and points. That's how we would normally do it. But what if we want an index as we go through. Now, if you're used to for loops in other contexts, you might say, like in C, you'd say like for I equals 0, oops, I equals 0, I is less than 10, I plus plus, and now I have this I, and then I would go through my array of points, like points of I, and then point gets points of I. And this is how I would like extract all my points one at a time. In Python, you can do this thing where you could say for I, or whatever this, you can make this whatever counter you want, and point, and this is going to bring out the points one at a time, and it's going to count up from 0 to however many points there are, minus 1. And so I can do things where I can index into arrays using that I. Okay, so what are we going to do? We're going to set the x and the y values, and it's the exact same thing that we did before, similarly, with drawing points around a circle. And I'll read this out loud in a second. I think we need this rotation. Of the rotation. Okay, so for each point, we're going to make an x value where we're going to multiply the existing point's x value by the cosine of the rotation. This is assuming our rotation is coming in as radians. And then we're going to subtract the y times the sine of the rotation. And this is how you rotate a point around the origin. Right? And then we're going to do the same thing for the y. So we're going to say the y is the y value coming from the point times the cosine of the rotation plus the x value of the point times the sine of the rotation. So watch your signs here. But what we're doing is we're taking for the y, we're going to take out the y value and multiply it by the cosine of the rotation and add on this, whoopsie, add the x times the sine of the rotation. Right? Now again, there's a more NumPy way to do this. You can like replace these in place, but we're now just going to rewrite x, y, 0. We're just going to put that back. And that is how you rotate around the origin. This thing right here, you're going to recenter on the origin. You're going to pull all the points out. And then you do a little bit of math to rotate the point around the origin. And then you add back in the displacement that you took away in the first line so that you're centered back where you were. Okay?
TDU has matrix functions, which
Does this.
Which would avoids you having to deal with the cosine sine, trying to remember what the equation for rotation is.
Really? I got to dig into TDU more. I wish I had done that. I'm sorry.
Can you show that whole thing?
Yeah. So we're going to make an array of zeros that has 5 rows of 3 columns. We're going to calculate half the size. For the first point, we're going to the left and down, so minus, minus. And notice these are all center of 1 and center of 0 here. We're going to go to the top left point. That's to the left in the x and up in the y. We're going to go to the top right point. So notice this is points of 2, 1, 0, 1, 2, 3, 4. We're going up and up, plus, plus. For our bottom right, our third point, we're going up. I'm sorry, we're going to the right, and then we're going down. So plus and minus. For our bottom left, again, we're going minus, minus. And then we're going to rotate. So we're going to subtract. Notice this is minus equals here. Minus equals, which means subtract in place and reassign it to the value. The center, the x and the y. We're extracting 0 and 1 from our center, which was passed in as an argument. 0, 0 as the default. And then a 0 for the z value. And then we're going to enumerate everything that's in our points. We're going to pull them all back out one at a time and we get an index into that. Our x value is going to be the x times the cosine of the rotation minus the y times the sine of the rotation. And our y value is going to be the y times the cosine of the rotation plus the x times the sine of the rotation. And we're going to put that back in right where we got it. And then we recenter. Now, all of this is to create an array of points that describe a square that has an arbitrary rotation and an arbitrary size. It's actually useful as it is, but we need one more thing to make this really useful, and this is going to be helpful with just about everything we do from here on out. And we're going to call this array to line. So let's just write above this, array to line, and I'll scroll down a little bit. Oops, array to line. It gets the script dot, and it gets an array. Colon, right? And we're going to, just as always, we're going to do a line of the script dot and the length of the array, right? So now we have a line with as many points as there are what we're assuming to be points in this array. So L gets line of script dot and then len, L-E-N, of the array. All right? And we're going to enumerate these things again. Again, there's probably a more NumPy way to do this. For I, comma, p in enumerate array, whoops. The line array, I'm sorry, we're pulling the polygon out. So we did this before, line point p. So we're going to pull out the poly number I. I'm sorry, vertex number I. So this L is containing a poly. We're calling it a line, but it's a polygon of X number of lines that's open, right? So we're going to pull out vertex I. We're going to pull out the point that belongs to that vertex. And we're going to pull out the position of that point. And we're going to give it a new value. And that value is P of 0. Oops.
Sorry,
Yes.
you should fix the equal for an int.
Yeah, why is it complaining about the?
I don't know.
Fix it for an int. It's you put an equal, but it should be an int. Or I
Couldn't be more right.
Oh, okay.
Right? So this is pretty straightforward, right? And then we're going to return our line. So what we're doing is we're making a line that has as many points as there are entries in this array, which we're assuming to be an array of values of 3 values, right? And then for each point in the array, we're going to pull out the points one at a time. We're going to tell the vertex that belongs to that line to move the position, that's this big P, this is a big P, of its point to the position in that array. Now we're indexing into this array because we're assuming that this is going to be a NumPy array. And this is a workhorse. This particular function is going to let us do stuff very quickly, ostensibly faster than we could if we did it with a Python array, because it's NumPy. If these arrays get really large, this should be better. All right, so now that we did that, in our, what do we call this? Square. It's a lot of code for a square, right? Sorry, I'm trying to find my square. Square. Nope. Find the next one. Can't find my square function. There we go. Okay. We're just going to call this function that we just made. So right here at the bottom of the square, we're going to say array to line with the script dot and our points. Right? Let me scroll down so you got that. Array to line, script dot, points. There's a lot of opportunity for error in there, so I'm hoping we're all on the same page after that. Looks like I'm not. Hi there. Oh no, I did it. Hello. I'm going to hit A and H to home. Yep, and there it is. Hopefully you got the same thing. Oh, and Landon just showed me this cool thing. If you go to your viewer and hit A, and then right-click. Is it display options?
No, you have to right-click.
Oh, I'm sorry.
Like the network background.
Gotcha.
Not on the op.
Oh my gosh.
Click on the blank space.
Display. Okay.
Yeah.
So ignore what I said. Click on the background of your network and go to display, backdrop geometry,
You gotta be
Oops.
careful.
and render it. Oh my gosh.
Can you show the code again?
Yes, sir. Sorry, I was excited about that. So we've called our square from our script dot. right? And let's go back to this. We should be all on the same page with this, I think. We're going to say array to line. And I'm assuming there's errors everywhere, so let's get on the same page. There's a payoff to this, I promise. Does everybody have errors?
Yes. I have a module compilation error.
Okay.
R equals import dat hard 0 TD custom import.
Try middle clicking on the text dat that has your drawing code in it, because that one probably has an error on it too, right?
Oh, yeah.
That should be a better error.
Oh, yeah, that is invalid syntax, definitely. Okay. Oh, yeah, I just forgot the colon.
Who else has problems? Does anybody have a square? Does everybody have a square? Does anybody? Let's get on the same page with this. So we can sample chops and draw squares. Big man's coming. Does anybody else have errors? Everybody's a square, really?
I have a triangle, but that's probably
That's cool. Out of range. Okay, so let's go to your array line.
No, that's fine.
So I recognize something, like trying to recognize something from this. So probably what's going on here
I have this wrong. I have like 0, 1, 2, 3, 3.
zeros.
All this stuff is correct.
Yeah, that's.
Should we do line? I think I'm going to show this because I've seen this a whole bunch. I think I messed up pointing something out early on, and I've seen this problem happen a lot for folks. Wow, we've written a lot of code, right? All right. All the way up at the top, everybody make sure, please, that your line function is calling, for the first argument to append poly, is calling with num points and not the number 2. Because if you're getting index out of range errors and stuff like that, you're probably drawing a line with 2 points and not num points. All right. So array to line is going to be super useful because now we can make an array of any kind of points, and whatever order they're in, we're going to draw a line in between them. So we can use array to line to draw circles as long as we can mathematically or anyway, in any fashion, describe a bunch of points. We can draw a line between them in sequence. And really, like, all these polys are just a bunch of lines, right? There are Bezier curves now in SOPs. We're not going to talk about them today. They're a really cool way to make curves and stuff with only just a few points. They're extremely heady, and the math is totally beyond me. But you can do curves with Beziers, but the closest thing you can get to a curve with what we have now is just drawing a bunch of points in sequence. And so I have a circle method. I'll share these with you after the talk and everything, but I have a circle method that'll let you draw a circle with a certain resolution. So I believe, I haven't tested it, this is what came to me last night, is that if you draw a circle of resolution 4 or maybe 5, it should draw a square. But this is our square. Does everybody have a square? I'm sorry, import what? NumPy as p. It's all lowercase and p. Okay. All right, so no, NP, NUMP1. Exactly. I'll be right back. save in TouchDesigner as well as in Sublime.
Is it okay if I scroll this down a little bit?
Sure, yeah. Middle click on your oh yeah, not equal.
Oh shit, I fucked it up.
First, can you show a rate line?
A rate line?
Okay, L of I, the index I, right up there.
Yeah, so this one is square. So you see here,
And you're calling your units.
I think you have an extra 4 line. So try deleting that line. And let's see if it works.
And then you're going to assign that position the P that you got out of it. You may just go ahead. Yeah, the P 0, P1, P2. And then you're going to return the yeah, and then return the Everybody good? We're about to do the sampling tops and chops. Well, sampling top to chop, sample to chop. Use a webcam. Crash computer. Lower because it's what you index. The big P is position. Yep. We're not calling it. Oh, I see. Yeah, this should all be grab all of it. Click there, just left click, shift. And now hit all the way down to the red line. And now hit control. Yes. Square. Exactly. Oh, I know. Let's go back to your this callback. Call the square. Draw. Square. 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 You got an error. No, SQUAR. This guy.
I did there for Christmas. 1 month.
Square, right at the very top, first line. Oh, great. Do I ever? Yeah, tons. Oh, here you go. Need a color? Yeah. Okay. Okay. So, why do we do that? Well, now that we can draw squares, we can do all kinds of fun iterations of squares, different sizes, blah, blah, blah. But what I want to show you how to do is TouchDesigner specific. So, real quick, go back to your TouchDesigner project and save. Go to your palette, and in the palette, in here somewhere, I think it's under generators, is a tox called noise. You're going to drop noise in. And for now, we're just going to take the noise that we have. Connect that to a null. And then from the null, you can do this a couple ways, but you're going to drop a top to chop. Boom. Now, when we do this top to chop by default, I'm going to close my palette again so you can see what's going on. Everybody have noise and yeah, top to chop, great. We're just going to we don't need all this. So I'm just going to use the R value. If you were using something like your webcam, you might want to pack your values into a Luma channel, which there's a top to do, whatever. But I'm just going to use the R value because this is monochrome noise anyway, I believe. It's RGBA. Doesn't matter. Okay. So I have this noise in here, right? And what I want to do is I want to go to crop, and I want to say full image. All right, you guys see that? Crop full image. So now I have, I don't know why those values are changing. Floating point? No, they're really changing.
It's because it's the current time.
Oh, yeah. Got it. Okay. So because this noise is 720p noise, I have 1280 samples of 720 channels of floating point noise. And we could consider that to be something like a matrix, which what it is basically is like for every pixel that we had in that noise, we now have a chop value that we can get at. I'm going to drop this into a null, and I'll call this null noise or something. I don't know. Doesn't really matter. But what I'm going to do is I'm going to go back into my sop to chop, and here in the code for my sop to chop, I'm going to say up and on setup parameters, I'm going to say P.
Can you please show it one more time?
The noise? This guy? It actually doesn't matter what the noise name is, or the null name. Yeah, next frame. Mm-hmm.
Did you modify anything?
All I did was get rid of some channels. I deleted the RGB because I only really want the red. I'm sorry, I deleted the GBA. My fault. You can use any channel you want, as long as you only use one. Right? And then you're going to crop to the full image. So everybody got this? You got 720 channels of 1280 samples.
Did you change anything in the noise top?
I didn't. Nope. If you middle click on your null, you should see it's 1280 by 720.
I have a bug.
You have a bug.
Yeah, on top 2, when I remove some of the channels, I lose everything.
Did you go to crop and say full image?
No, once you delete like one of the channels, and it goes away.
Yeah.
Maybe try it again, like delete it and drop another one?
Yeah.
You did? Okay, so
Image is also bug.
I tell you what, maybe Elbers can help you delete those channels. When she deletes, when she deletes some of the download channels from the top to chop.
Is it a Mac?
We're running low on time, so I just want to. I'm gonna press ahead a little bit, even though we got some folks lagging behind, just because I want to make sure you guys get a drawing out of this. Page, append chop. Is it all caps? Sorry. Let me look at my crib sheet, my notes. Yeah, it's all caps. So you're going to say append chop, C-H-O-P, all caps, right? And you're going to give it a name. I like calling it chop. Has to have a capital first letter. And I'm going to give a label, and I'm going to say chop, right? So you say P gets, you don't have to catch the P, but page dot append chop, C-H-O-P, all caps. Chop is the name of our variable that's going to come out of this, capital C-H-O-P. And then the label equals quote, whatever you want to call it. And now, if we go back to touch, we're going to go to our script and touch our setup parameters. We're going to pulse this, right? So now we go back, we can see we have a chop field. And what this expects, if I try to drag a top into it, nothing. Well, just drag the top over there, right? And if I try to, I can't put a value in there or whatever. What it wants is it wants a chop. Boom. So now I have a reference to that chop. Now I could just reference the chop in Python the way you would any other way, which is to say op and then quote the name of the op. You could do that. But this is a nice clean way to keep your interface rocking in your script stop. Right? So now if I go back to my Python here, I can say, whoops, I'll scroll down so you can see this. Chop is my par chop. Oops, C-H-O-P. Right? So I'm referring to, again, by this value of the custom parameter that I made, I'm referring to this chop. And I'm catching it in an argument called, or a variable called chop. Everybody make that work? Who needs help? Yeah, so you have to pulse the setup.
Anybody else gonna make?
Drag it in there. Okay. So that's a way, if you go through the documentation for any of the script ops, you'll see that you can create, as a member of the page class, there's append, or member method of the page class, there's append chop, there's append top, et cetera, and it makes those fields that in the TouchDesigner interface are strict about what kind of input they get. Yeah. And you'll see now I have this dotted line reference, which if I mouse over it, will tell me that I, connected this param named chop with a big C to that null. Now I could just reference that in Python. I could say op quote null noise, but
Can you show a script?
yeah, sure.
Up there.
Oh, so I'm saying append chop, big, all caps.
Also, just an issue I had in case anyone else has it is that you have to capitalize the parameter names
You do.
or they won't work.
This has to be a big C. The first letter has to be big.
Yeah.
And the rest have to be lowercase, otherwise it also won't work.
There you go. Okay. So big first one, and I think you can have no spaces and stuff like that. So this is a reserved namespace with the first letter capitalized, I think, for par members. Yeah. Cool. All right. So here comes the fun part. I can't even remember what drawing we're doing right now, but so what we're going to do? Did you have a question? I'm sorry. Scroll up. Oop. Yeah. Okay. I should be able to do this in my sleep because I've been doing these over and over and over again. Here we go. So what we're going to do is we're going to make a drawing, and this is a new drawing. So here in the drawing section, we're going to call this Berlin, we'll call it whatever, chop squares. Chop squares. Right? Everybody knows what the first argument is going to be. Script dot. Right? And this is a motif that I come back to. If you're doing something as a grid, I always do it the same way, which is X, Y, grid scale X, grid scale Y, and then we're going to reference a chop. So everybody got this far. Function's going to be called chop squares. We're going to always pass the script op in. This X and Y are going to be how many, what's the dimensions of our grid? Because we're going to do a grid of things. And then we have a grid scale, X and Y, and that's how big is our grid. Typically, I like to do it the size of an A4 piece of paper. Now, there is a magic number that connects the Axidraw are really Inkscape to TouchDesigner, and that's 90, which is the DPI. So if you multiply the SOP space, and I have this in my AxeEscaler utility, but you multiply SOP space quantity, that magic, whatever the unit is, I don't know if it translates to the real world or what, but times 90 gets you to the scale of the paper. So A4 paper is like 12.67 inches wide, times 90 in TouchDesigner units gets you whatever. So I tend to pass in the A4 scale for this. You can pass in whatever you like to make your drawing. You'll see we can play with that in a second. Okay? So we're going to do a loop within a loop. This is how you make a grid. For I, and this is just convention, in range X. And then a nested loop for J. I and J are just the way people normally do this, in range Y. So we're doing a loop within a loop. So we're going to do our columns first. I'm sorry, our rows first, and then our columns, I think, or maybe our columns then our rows. Doesn't matter. You'll see. We're going to sample our chop. It's really simple. It couldn't be easier. We're going to say chop of I, chop of J. So this is channel. The I is the channel, and the J is the sample. And so if you look back in TouchDesigner, I'll go back. You can copy that in a second. But if you look, I have 720 channels and 1280 samples. So our samples are our columns of our array, our Y values, and our X values. This stuff is always confusing to me, but we're sampling from channel of I, which is our X quantity that we passed in. That's how many times we're going to sample across the thing. And then J is going to be our sample channel. And I'm realizing now that I need to multiply this by a value. Oh, we'll come back to this. We're just going to sample. This isn't strictly right. Yeah, let me find. Oh, yeah, okay, here we go. So we actually need to make UV values. So it's not going to be I and J. Hang on one second. So our U, and this is, we're talking about this in terms of a texture that's coming in from our top, is going to be the fraction that we've gone through of the X's times our width. And I'm just going to hard code this because I know that we're using a 720 thing. So our U is the floor of this fractional value, I over X. And you see we keep doing this over and over again, right? This is like a fraction of how far we are into a loop, I over X. And we're going to multiply that by 1280. So that tells us how many samples in we're going to go, or channels in. Is that right? I'm getting these backwards. And then we're going to round that down with floor.
Why don't you do that for the Y?
We are. Yeah, I just one at a time here. But V is going to be math.floor of the same thing. It's just J over Y times 720. Oops, 720. All right. And just so you guys see this, I'm going to shout it out loud. I'm not doing I and J any longer. I'm doing U and V. Whoops. What the? U and V. Whoops. Goodness gracious. U and V. And let me just, I didn't save in TouchDesigner before, so I'm going to do that. Save. All right, let me bring the code back up.
Why aren't you using non-channels and non-samples instead of hard coding?
Yeah, that would be smart.
You have the chop already.
Yeah, sure do.
Is that one of the arguments being passed in? Like, I don't know what just the X and Y is.
X and Y, yeah, we're passing these in because this is how many rows and columns we want to make our grid. So if we want to,
adding like a res X and res Y, presumably, right?
that's what grid scale X and grid scale Y are. You'll see them in just one second. I'll show you. Whoops, yeah, I did V twice, huh? Let's call this val. So this makes sense to everybody. What we've done is we've divided up our top into a grid of an arbitrary resolution. It's X and Y, which is what our drawing grid is going to be. And then for each of those points in the top, we're sampling out a value out of the top to chop that we did. So now we know at each point what the value of the R channel is, because that's what we're passing into our cells. Let me go back to my, what are we doing, square or something? Perlin, I called it Perlin because I was using Perlin noise before. Perlin grid, yes. Okay, here we go. So now we're just going to draw a square at each point. What's the point? Well, the center X of the square is going to be I divided by the grid scale X. And the center Y is going to be J divided by the grid scale Y. So the grid scale allows us to rearrange what our drawing size is, and the X and Y allow us to determine how many things we're going to draw in that area. And the X and Y also determine where we sample on the top that we're working from, whatever that is, whether it's a webcam, noise, a ramp, whatever you want to use. That's where we're going to sample in some information. Now, there is noise built into TDU for right, Berlin and, not TDU. Oh, I'm thinking of GL. Never mind. So this is a great way to get noisiness from our top. And that's what we're doing. We're using noise for the moment, but you could use your webcam or something like that. So now we're going to use this thing that we did, which is square. We're going to pass it the script op. We're going to give it our CX, CY, because this is our center, our first argument. I think actually, oops, I think we put those together into a, let me look. Yes. So our center is a tuple, CX, CY. And then our val. So this is the size argument. So let's go ahead and put this in. Here, I'll scroll down. And I'll name these so you can see them. Center, size. And again, I'm just going to do a magic number because I know this is going to look a little bit better. But let me just put in a tiny multiple of the value. And then I also know that it's kind of, well, let's just do that for now. And we'll play with the rotation in a second. So that's either going to crash TouchDesigner. I haven't actually done it over here yet, but let's just go back. Let's go back to TouchDesigner and save. Okay, and I'll bring the code back up. And over here, I'll save our square, because we like that. And we're going to draw chop squares. And we'll say, we're going to give it the script op. And I don't know, let's do 10 by 10 for now. So 10, 10. And then I think the paper's like 12.9. You can do whatever you want for all these numbers. Just don't do big numbers. And then pass it the chop. So like double-digit numbers max. And even that may be big depending on what kind of laptop you have. You may want to use the numbers I did.
And so the chop squares function doesn't need to return anything?
No, so this is a drawing. And in the drawings, draw. So the distinction...
Because it's in a script sock, that's...
It's being called by the script sock, but the distinction that I'm making generally is like I'm making these tools that... these actually draw too, but... This didn't need to return it. You could return the array or something like that, but I don't know. That'd be cool. Maybe you could do something with it later. But really, these draw. Yeah, exactly. So I think, I go over here. I got an error. What do we got? What's not subscriptable? My par, 88. Chop. Oh, right. I need to pass this. Hang on one second. You can't just pass the chop. You need to pass a reference to the chop, I think.
Like op in parentheses and then chop variable?
Here you go. Yep, exactly. So this is what we want to say. I'm going to copy this. My crib sheet here. So the chop is actually going to be, whoop, SO, par chop, the val. And you're going to cast that as a chop. Because I believe the val comes in as, or as an op. The val comes in as a string. Gosh, I hope I'm not.
I thought it was an op already.
I get an error when I do that. And then this does work, I believe. I still have an error. What's your problem? 988, chop squares. 88. Yeah, that's what I was getting before. Did I save this? Am I editing the right thing? Yeah. No. Huh. Did I, as is very likely, did I do that wrong? Give me 1 second. My crib sheet over here. Append chop. Yeah. And then my chop gets op. Yeah. Am I passing it a different way when I do some of these drawings that take chops? Squiggly. Sorry, guys. A little peek under the hood here. No, that seems right.
Show me the error.
Yeah.
I think, do you need a val
I'm sorry?
on the pop?
It says none type object is not subscriptable, and that line in question is the this line right here, chop. of UV. Sorry? Oh, that's a good question. Make sure I did the right thing. Should be the chop. Null noise. Yep.
I think you need the up pull. I think just val left.
Okay, let's try that. Whoops, that's the wrong one. No. Can't multiply. Oh, okay. That's progress.
So it isn't off anyway.
Yeah, but you have to call the val. So everybody make sure that you're saying dot val after you ask for this par. And then, what was the other complaint that it just had? Can't multiply sequence by non-int type of float, line 91. Sequence of float. So this must be a...
Without the sentence.
Sorry?
When you write the last line,
Uh-huh.
the center equals,
Yes.
mine is working without this.
Okay. I think it's complaining about this. I think I've got an error somewhere else, but I'll try that. Nope. Cannot convert string to float. Yeah. So I'm getting a string out of this. Isn't that odd? That must be this val thing. Have you done this right here?
Debug the chop.
Uh-huh. Or you mean in the script sop?
Yeah, well, hang on.
Well, I just did that in the loop. Oh, so tiny. Null noise. Null noise. But it's not a reference to an op. Maybe if I get rid of the val again. I don't know.
Well, I'll give you a part.
Yup. Oh, I'll give you a par object. Right. How odd. I swear this worked back in the lab. Chop. Chop.
When they debug again?
I'll do it over here maybe. So in the script, it's a string.
Debug the type of it.
How do you do that?
Just put in parentheses, put type around it. This is called type. You can just put.
Oh, love it.
So that'll give you a string. So put that inside the debug.
I see. Yes, of course. Class string.
So it's a string. Yeah, so you do need the op.
Yeah. Well, we did that and it didn't work. Let's try this one more time.
In the uppercase chops.
Yeah, it's uppercase.
Yeah, so that works now.
Uh-huh. Does this work? No. Yeah, not subscriptable. None type. Is it a reference thing? Does anyone have this working?
Yes.
You do? Yeah. I have a typo somewhere. Chop. 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 Chop.
Yeah, it must be out of range.
I suppose that's possible. Yeah. You know what?
It's
I bet
probably-
you it's these magic numbers.
The chop probably, yeah. Like the chop probably isn't getting none.
No, you know what? I bet you it's this.
You're getting a channel.
Let's try that. Oops.
There you go.
I could probably home that. Yeah, I'll catch you guys up if this works. I don't think it did, but... Yes, it did. Okay. So I got my 1280s and my 720s mixed up. You saw me doing that when I was trying to narrate what I was doing. I think we're still a little funky, but... so you see, the the columns and rows are something I'm never going to be good at. But your x is going to be multiplied by 720, and I should have as someone very wisely recommended, just refer to the number of samples. Yes, you deserve the credit. The number of samples and the number of channels. But instead I put in this very error-prone magical number.
So why is the X by the height and the Y by the width?
Because now you're really asking me to prove how little I understand this. But basically the X is referring to the number of columns. Or,
It seems transposed, which is
yeah, it does. Yeah, it is transposed.
Okay, well, that's like, so you ended up with something that's taller than this Y, which is fine.
Yeah. There's something very wrong here, but it's actually not
It's not that right. It's better than what I have.
super important. I'd have to think about it for a while and you would all smell smoke and they would evacuate the building. But what I do want to show you guys, I guess this has been, yeah, it's been transposed. I don't know why that happened. I got an idea. Let's just do, this is a hack. This is probably wrong. Whoops, no, I can't do that. But value.
Well, because the number of channels, right? Like the channels is the verticals, the number of channels, right?
Uh-huh.
They reference that first, so.
Yep.
Right, so that's reverse. So it's essentially like here.
Gotcha. Yeah, that makes
it's
sense.
essentially YX here.
That totally makes sense. So then probably what I should do is just here swap X and Y where I draw these. That's a dumb fix, but you guys get the idea. I swap the X and Y the way I'm plotting them. Whoops. So if I home on this, there we go. So now this doesn't look like much, but if I dial in on this viewer, and I would recommend you tread really carefully when doing this. I would save in TouchDesigner. I would go really slow. But I just want to show you what it looks like if I go like 100 by 100, for example, and go back to Touch. Yeah, it's chugging. Hello. What's going on? Is it crashing? It's very odd. Oh, there we go. Okay, so now this is starting to look a little bit more like my source material, which is this noise. And I can drag this over here, and I can show you that that noise is not all that exciting. But if I, let's say, I'm doing cellular 2D, if I were to scale to a bigger number, it's going to go real slow. And again, be careful. You will crash your computer. But I want to get a noise with a little bit more of a coarse texture. There you go. Is that, it's finer or coarser? I can never remember which way. That's finer. So I actually want to go, I don't know, like, well, it's going to recompute every time, so there's no winning. Here's a quick tip. Pause your timeline and change these values. Like 0.02. Oh, it's computing anyway. I should stop cooking. This looks like a crash. We're going to find out. Nope, we're good. Okay. I'm just going to change. I stopped cooking here, so I can do this without. Nope, still doing it in the background.
Oh yeah, I had to stop cooking to make my geo viewer work again. When cooking was on, like I couldn't change.
Huh. Well, I'm not really sure why it's still cooking if I stopped cooking. I'm not gonna lie, it makes me furious. I think I'm also doing a lot of printing, which is pretty dumb. Let me get rid of. Yeah. Could be. Although the noise recomputing is not what's taking so long. It's piping all that gobbledygook through Python. I see. Yep. Yeah, you might be right. You might be right. Anyway, so now you can start to see the forest for the trees here. You guys see what I'm talking about? Now, if I did this with, let's say, like the webcam, this would be changing in real time. It wouldn't be super performant. I'd probably want to drop those numbers back down. But you can do stuff where, like, whatever's in that top is whatever it is, and you're representing that with, in this case, the scale of a circle, and another, you know, like since we only have 3 minutes, I'm just going to give you an example of, I'm going to drop this down to like, I don't know, 30 by 10. But I'm going to add in over here, I'm going to say the rotation gets, I don't know, the val, or times 2 pi, something like that. So my value should be 0 to 1, and my rotation is now going to be 0 to 2 pi. Oh, my constants were kind of funny, but that's odd. I think there's something wrong with my math here. Yes, this is wrong as well. Well, let me just do 100 by 100 again so you can see this. Or maybe 50 by 50. And we got to vacate this room. All right, it's going to redraw. Boom. So now, if I were to zoom in on this, hello. Can I go in?
Yeah, to turn off cooking, it'll let you zoom in.
I think I'm just not selected on it. There we go. Turn off cooking, you think?
Yeah.
All right.
Yeah,
Hi. So you can see that these are actually not only scaled by, but rotated by the value that we've sampled out of that, which can give you a really cool texture, you know, when you look at this on a plotter. And just to show you one more time what I did, is all I did was I took the rotation value, that value that we sampled out of that channel is necessarily 0 to 1. There's a color value that came out of a top to chop. And then we're multiplying that by 2 pi to rotate the circle up to 1 full rotation, depending on what that sampled value is. And that can get you a really cool texture too. If I'd made this value even smaller, the circles would basically go away where it's black. And you can play with that, or you can play with nonlinear scaling or something like that. I hope that gave you a start, guys. I know that was kind of crazy. I'm going to post my whole library of code, which I'll probably put on a GitHub, and I'll continue to optimize using the TDU library and doing it the right way and getting NumPy cracking. You guys should, if you're into this stuff, follow what David Braun is doing. Join the Plotter's Slack channel, where there's a lot of conversation going on about this stuff. A new guy named Gio is doing cool stuff. He's new to TouchDesigner, but he really knows his way around it. There's a lot of cool people doing plotter stuff in TouchDesigner, and it's really inspiring. And I hope this kind of methodology makes sense to you. This is just one way to do it, but the idea being build up primitives, test them, make sure they work, then start to use those to make other drawings, and then you can start, you know, wandering outside of the script shop and doing things that are in Touchland, and then bringing them into this context to draw with them. I never got to perspective. I have a perspective thing that I'll post, and so you can grab the matrix from a camera and things like that. So I was going to do questions, but we're out of time. We're out of time? Oh, all right. Well, if anybody has any questions, don't feel like you got to stick around, but please shout them out. No, yeah.
What was the name of that stand?
Stanislav, hang on. Let me find. Oh, I don't have an internet connection. I'll write it here. Lichtfad. He is presenting in the GLSL talk tomorrow morning. But he has a bunch of courses online that are excellent. And his teaching method is very good. He's a whiz. I learned a lot of what I know from him. Yeah. Any questions?
Can you just, the final step of it is to export SVG?
Oh, yeah. Well, so you guys don't have this talks, but it's couldn't be simpler, really. You just get it, whoopsie daisy. Matthew's talks, SOP to SVG, you just give it a reference to a SOP, and then pick a paper size, tell it where you want it to write it. This is a directory relative to your Touch project. Give your file a name, and then pick a format. I normally do polyline only. I've had problems with the polygon setup. And then just pulse it, and it'll write it out as an SVG, which you saw me monkeying with Inkscape earlier. I'll just have this draw over the other one. Just going to drop the hammer a little bit more. Right? And then from here you can just plot. And so I've made another thing. away you go. I made another thing here in TouchDesigner called AxeEscaler. And this is pretty simple, but basically you pick a paper type and you tell it how much of a border you want around it, and it'll automatically scale your SOP space to paper space.
To have borders.
Yeah, to have borders and just to like fit on the page. It's got some problems, but it works. It works okay.
How did you make this design? Like this?
Oh, there's like nothing.
Approach, the image of Matthew, this is the same approach of drawing?
This image that you're looking at here?
No, the left.
Oh, no. That's an image that is scanned back in of a drawing that he did. It's a locked top. He scanned this. That's what it looks like though after you print it with a pen. Matthew made that. But this thing is just another script SOP, and it is this it? Yeah. Basically, you're just scaling. It's just a rescaling. You're looking for the extents of the thing, and then depending on what the aspect ratio is, you're rearranging it less the borders. It's actually pretty ugly. I'm going to keep working on it and like make it work better. The other thing, just really quick, since you guys are paying attention, I'll show you the perspective thing. It's pretty straightforward. You, whoopsie daisy, these are all drawings. You will make a comp. So many drawings. It's in here somewhere. Projection. Okay. You're just going to reference a comp. So in the same way, over in your script SOP, you would you made a chop. You just make a comp. So yeah, whatever. Append page. Append comp. Cam. And then the label is cam, right? Save that. And then you're going to pass that same thing. You're just going to make a reference to it the same way we did here. And you're going to pass that into your perspective function. And the perspective function can, what happened? Oh, wrong one. This one. Oh my gosh. You're killing me. Oh my gosh. Oh, it's on the wrong window. I'm sorry. Where'd my perspective go? Sorry, a lot of code. Here we go, projection. So you're going to take the projection matrix from the camera. This aspect ratio should be 1:1 unless you want a distorted image. Doesn't matter what the numbers are, but they should be 1:1. And then you're going to grab the world transform from the camera so that you know where the camera is in space and which way it's looking, and then invert that to get the view transform, or the view matrix. And then you're going to multiply the view matrix, the projection matrix by the view matrix for every point's position, and then reassign it to the point. That should be doable in NumPy, but I haven't figured out how to do NumPy operations on... Oh, no, wait. Yeah, I couldn't get the matrix math cracking on a NumPy array. NumPy is kind of new to me, too. But all you're doing basically is extracting the matrix from the camera that allows you to transform from SOP space to camera space. And what that lets you do is do things that have perspective. So if I bring up my version of things here, which is a hot mess because I just use it like a child uses a placemat. I'm going to find something that has perspective. I don't think any of these have perspectives. It doesn't matter. So what I'll do is I'll just copy in my input the dumb way. Here we go. So actually draw, copy, SO, and then draw perspective. I think I got to pass it the SO. Maybe I don't. No, I don't think I got to pass it the SO. Perspective. Still got a complaint. What's your problem? Oh, right. I didn't. This was before I got in the habit of replacing script-op with SO. There we go. What's your problem? Okay. Of course. There we go. All right. And now I can pass in something that has a little bit of dimension to it. and I'm referencing a camera. So if I put my background geometry to be this guy, you can't really see it. Well, I'm also rendering, so let me do my render, bypass. Of course, it's behind that thing. Hello? I can now move this camera around. This is an actual camera. And so I get all the free stuff that comes with the camera. Gosh, I don't know why that's not working. So I translate the camera. Why is that not moving? Referencing the camera. Oh, I got to pass the camera. No, the render was moving, but the yeah. Give me 1 second. I think I got to pass it the camera. Oh gosh. Projection. Yeah, I got to pass it the camera. So I think I called it cam. Camera. Camera. Ugh. Camera's not defined. Top cam. Lowercase c. Cam. Golly. It's the same thing. This pass by reference thing is really getting kind of funky. I swear that worked before. How do we fix this on our other one? That's how we did it. Oh, we're going to append object, right? It's huh. Well, I guess you're going to have to take my word for it. This used to work. But you can move the camera around and take the transform and the view and the field of view and everything from the camera, and it will give you perspective on your technically orthographic final product by actually moving the points in space by the matrix.
Is there any way to skip the recording? Any way to access
Axidraw?
Yeah. Any way to access Axidraw without going through Inkscape?
Yes. There's a couple different APIs. I haven't monkeyed with them yet. Yeah. There's actually, like, I think it's a REST API that you can use. And there's a serial protocol to control it called EBB. But you need to program in all your own safety and extents and stuff like that because you can tell it to just go to its extent and grind the belt. So eventually I do want to do real-time control over it, but I just got this thing and I just got fascinated with just doing the very, very basics just as a beginning. And I think the first detour I'm doing is through rules-based drawing. I just started doing some of that, which is fun, and that's really what you want to use Python for. And then eventually, real-time control would be very cool. It'd be a cool project to do together. I know that other people are interested. So guys, this is going to be here. If you need help with the dependencies, let me know. But we'll leave either this one or the other one out so you can draw on it.